Good day, good people. How's everyone doing today? Welcome to Thursday, the second best day of the week. First day of the week is actually Monday. It's not actually Friday. Friday is great. Monday is the best day of the week, but Thursday is the second best day of the week, not including the weekend. Today we are just pouring up a little. Maybe you can, let's see if you can hear. I don't think you can hear the crackling and popping of a little bit of LaCroix. We have to be a little bit fancy today. A little bit fancier than usual because today my wife and I are celebrating our third wedding anniversary, and so, you know, why not step it up a notch? There we go, and take the fresh taste of LaCroix Kirate Pame Baya. We're gonna sip on some, from a fancy glass. But thank you. It's our third anniversary. It marks the day that I officially successfully completed the longest con ever done. I successfully over 10 or 11 years convinced someone to actually marry me. So I'm proud of myself. She's a sucker, but I got her. It's all that matters. It's all that matters. But how's everyone doing? What's up, Sandpaper? What's up, Chelsea Carter? How you doing, Rollers? How's everyone doing tonight? Quap till you drop. Hey, we should play some QOP. Prime's pretty good at it. Thank you, baby. Prime's pretty good at it. I'm pretty terrible at it. QOP's pretty fun. Maybe one day we'll play some. How's everyone doing? Pink Slandian, how you doing? Hey, Sean, always good to see you. I'm interested to know, I'm gonna go back and watch some of the videos to see if everyone's chat name stays the same color. I like that everyone's name stays the same color for me on my screen, so that I can identify everyone. It's kind of nice. What's up, Devo8? How you doing? Uncle Bill, what's up? 88 Opus, Enigma 5N, how you doing? Twitter link included as an extra dot, so it broke for me. That'll do it. So let's see. Command. Actually, let's see. Where is it? Do I actually have a Twitter command? Well, I'll fix it in a little bit. AJVN, I appreciate it. Thank you guys very much. Appreciate the love there. What's up, MG Iced? Lily Hazel, Pop Logics, how's everyone doing? K Cole, hope everyone's having a great day. Hat Matter, I love it. Thanks, Devo8, so much for the bits. You're always so supportive. Thank you so much. What's up, Sharky? What's up, man? Miss Gray, welcome to the channel. Slime USA, Slime Yeshua, how you doing? Mickey, Artman, good to see you all. Greatest Rob. Stefan, how's everybody doing? Coderholic. All right, tonight we are going to be diving into some last class we partook in some dank data types. Tonight we'll be partaking in some dank data structures. Now this is going to be an interesting concept that's going to be confusing to a lot of people. Like I said last time, I've had this conversation with a few people. What we are going to be learning tonight is they are also data type. These data structures that we're going to be learning tonight are kind of the base data structures that they're data types as well, and they help make up some of the grander data structures that people are usually thinking of when they're thinking about doing algorithms or they take a data structures course. These are the underlying things that help out with those, but they are in fact data structures, but they are also non-primitive data types in a lot of languages. So I just want to clear that up right up front, but we're going to be going over a lot of it. There's not a ton of content, but I think the concepts might be a lot. Tonight might be a bit of a cognitive load. Hopefully we're all prepared for it, but I don't think it'll be too crazy at all. So hopefully we should be good. My color is usually consistent for months on end, but this week is a special event for another streamer. The color will change daily. Oh, that sounds fancy. That sounds very fancy. The oatmeal stout you recommended, I did not see it yet. I will check that out. I'm a huge fan of oatmeal stouts, so I will definitely check that out. Should I download anything to get started? Chelsea Carter, first off, welcome. It's so good to have you. Tonight, probably not. I don't think you need to download anything right now. you'll just need a text editor and access to run Python. You probably need to download and install Python. I can point you at where we did that, or I can point you at some better videos for installation. Tonight, I'll have you just go to a site called repl.it that someone here taught me about, that you'll be able to follow along with. We'll be doing, you'll be able to do everything in there. So no need to download anything. Just hop onto that site when we get there, and I'll paste it in here. I do like Guinness. I definitely like Guinness. Guinness was one of the worst drinks I ever had when the first time I had it. And then, you know, as everything else, your palate matures, and I learned to love it. I mean, beer was disgusting to me when I first tried it. So here we are. Happy belated, D Jackson. Happy belated. Were you born in 1911? You're up there in age, and I respect your seasoned wiseness. How you doing? Happy birthday, happy belated. Okay, Johnny Walker. So I'm not a huge liquor fan. I'll drink some whiskey. I try to get into it. I'm still trying to work my way in. There's whiskeys that I like, but I don't know, I'm just not it's not something I've grown to love yet. I've grown to appreciate it. I've actually been to a nice whiskey bar with a few people from work a few times, and I've learned, I understand it now. I definitely understand why people love it. I definitely understand the different flavors now. I definitely understand PD versus non-PD, and like when people are like, this one's very smoky. I'm like, oh, okay, I couldn't taste it before. Now I can taste it. So I get it, but I don't love it yet. You know, I don't love it yet. I'm gonna get there for sure. But what I do love is this nice LaCroix Curate. Bubbly perfection, amazing. It's actually much better when you drink it out of a wine glass. Pretty good over there. Let me make this a little bit lower. Okay, let's get logged in real quick, so that we can talk about these Danker data structures. So last class, we talked about some data types, and those data types, we talked about data types last time. While those were individual data types, and it wasn't every single data type, but it was some of the more important data types, we kind of learned about how you could interact with them and do some things to them, manipulate them. And I just, you know, saw how they worked a bit, just explored a little bit. We're gonna be doing the same thing tonight with data structures, and kind of just playing with them in the same way. This will build off of our concepts of data types. For you to have data structures, you must also be using those data types. So it's gonna be pretty cool. Beastco, thank you so much for the tier 1 sub. Beastco, welcome. I see you everywhere, all around the Science and Tech channel. So I appreciate you sending me love over here. How you doing? Here comes the health police. Oh, we got health police here. Oh, alcohol is poison for the body. That's what I heard. Hey, I get it, you know, but there's a lot of things that are poison for the body, like McDonald's. I mean, when I was eating McDoubles from 2004 to 2008, you know, to survive, not really to survive, but like because they were $1 and they were amazing. I knew they weren't good for me, but I really thrived during that time. I was probably in the best shape of my life. So yeah, sure, it's poison, but you know, you make trade-offs. You pay for it later, or you work it off later. You know, it's you know, you just gotta, everything in moderation. You know, you can eat McDoubles and drink alcohol for 50 years and then chill for 50 years. So I spent 21 years of my life not drinking alcohol. That means I can spend 21 years of my life drinking alcohol. Yep, because that's how the universe works. But it might be, I don't know if y'all heard about the new scientific discovery of you know, the what do they call, the tau something, some kind of particles that maybe supporting the idea of a parallel universe that might be moving backwards. Pretty interesting. Definitely pretty interesting. I watched way too many videos on it today. Yeah, it's pretty interesting. Like, this is like a genuine scientific find. It's a real thing. This is not a conspiracy theory. They did not find a parallel universe. They found something that supports the theory of parallel universes moving backwards in time. It's pretty interesting. I don't know enough about physics or anything. They were saying a lot of big words that I didn't know, but you check it out. It's pretty cool. It was just pretty interesting. It's kind of fun, but cool. Let's get going tonight so we can get out of here and I can go spend time with the missus. We have food. We got some nice Italian tonight from a place called Amici's here in Baltimore. It's kind of our celebratory spot. So, you know, chicken parm is my favorite. So got a little chicken parm, a little bit of tiramisu. I think we got a little bit of wine as well. So it's gonna be nice, you know, going into the 3-day weekend, gonna be pretty beautiful. Even though it's gonna rain tomorrow and a little bit on Saturday. Where were you? This deCoded tonight? Yeah, we're deCoded tonight because we're gonna be, yep. Danker Data Structures, the slides are here. Notice that the homework in the material this entire week has been light. The reason I'm gonna express this at the end as well, but this week's information, the extras have been light. What I want people to do is take some time, go through things last week, kind of get a little more confident in the things that we did last week and this week, and just kind of play and practice and just do whatever with that and kind of ease your mind, because we're about to start using these things, and I think that's where it's going to be I think it's gonna be a little tough, so I don't want to burden you too much this week with that. Next week, starting next week, also the you'll also be getting assignments, like graded assignments. You actually have to download things from GitHub and submit them. I'm trying to get the GitHub. GitHub has like a classroom you can do graded assignments through. I'm trying to get it to work, but I don't think that's gonna work. But yeah, it'll be some stuff where you can actually download some code, and you might have to modify it. I give you some instructions on, hey, I need you to do this. So yeah, we'll be doing that. Yes, Chelsea Carter, you can do exclamation point classroom. So I actually pulled a bunch of information from it because it was just a lot, and you know, I just, again, this is we're still learning what is a good pace for things. We're still learning the best way to implement things, and I don't know, I hope pulling some stuff because there were a lot of like resources this week that were going to go out, and I was like, this feels like too much. Okay, yes, MG, tonight's agenda is data structures. It's really like data types continued plus data structures a little bit. So Danker Data Structures, Dank data types to Danker Data Structures. Without structure, there is only chaos. All right, so we're gonna be into code a lot tonight as well. We're gonna be learning a concept, hopping right into code, seeing it in action, because I think that's the best way to do some of these. So what the heck is data structure? So you probably have been trying to learn how to code, and you've Googled stuff and you've seen videos, and everything talks about data structures and algorithms. You want to get a job at Google, you gotta know your data structures, you gotta know your algorithms. While that's true in a lot of cases, it's not as scary as it sounds. Neither one is as scary as it sounds. They can get pretty tough, but at their core, they're not all that crazy. What the heck is a data structure? A data structure is our particular way of organizing data in a computer so that it can be used effectively. Pretty simple item. It's not some wild thing. It's a structure of data. It's a particular way of organizing data in a computer so that it can be used effectively. There are a number of ways to do these things. The things that we're going to talk about tonight, like I said, are data structures that are actually non-primitive data types. So they're actually inherent kind of data types to these languages, but there are other data structures that I did give you access to in the classroom that go deeper, that we'll be learning probably in the journeyman level course. Like as we're going into that course, we'll probably pick up a lot of those concepts again, like linked lists and things like that. But we're gonna be talking about those things tonight. So the first one, we're gonna hop right into it. And these we are going to cover the common data structures in Python first, because the ideas of what's here kind of carry across the board. And I thought it would be, because Python doesn't have, because each language handles these things differently, it can be a little weird. So we're going to focus on Python for most of this. I will show you some things in Go later on, but after we have covered mostly the Python data structures, and kind of talk through kind of the idea of data structures and kind of how to work with these things. So the first one is a list. A list is a data structure in Python that is mutable. And mutable, it also means changeable. So it's changeable. It's an ordered sequence of elements. So first thing I want you to do is start to think about data structures as a collection of data. And so what is data? Again, think about those data types that we learned. These data structures are going to be collections of data types. So this list is just kind of just like your shopping list. It's a data structure in Python. Python's one of the few places they call it a list, actually. So I want to be very clear with that. We're gonna talk about what this is in other languages as well, or what the idea of something like this is. But it is a mutable or changeable ordered sequence of elements, and I should really, you know what? I'm going to bold this. I'm going to bold ordered because it's very important. It is ordered sequence of elements. So 1, 2, 3, 4, 5. Each element or value inside of that list is called an item. So everything in there is called an item. Lists are defined by having values between square brackets. And so I'm going to show you that. So the same way you should be thinking of string, when you see those double quotes, when you see these brackets, you should be thinking lists. Now, the concept that we're covering here is actually in some languages we're covering an array. An array is usually what something like this is called in other languages. There's a few caveats in there. Even in Go, this version of this is actually called a slice and not an array. Array is a different structure of data, but a very similar, has the same underlying pieces. But it's a list of items. It's a list of pieces of data, a collection of data. It's changeable. The things in there can be changed, but it's ordered. There is an order to it, and that order matters. That is what's important to know here. So let's go in and let's see this in action. So for everyone, again, who's not set up to run Python or not comfortable kind of running things locally, head over to repl.it. Head over here, click start coding over on the right, and just choose Python right here so that you can follow along with us, and then choose create REPL. And so what you're going to do is anyone who's new to that, you're going to type your code. Whatever we type, you can type right here. And when you're ready to run it, you can go ahead and click this button and it'll spit out over here. All right. So everyone who's not set up or just wants to do it here, feel free to do it here. We're not doing a bunch of crazy stuff tonight, but we are going to be writing a fair amount of just messing around like we did last time, messing around with code. So I'm going to head into our terminal. I'm going to find the place I want to be. I want to be in deCoded. I want to make a directory called data. I never pushed up data types, I don't think, so we can do that tonight. I'm gonna go into this data structures folder I created. This is not for you to copy. You don't have to do this part. Okay, larger. Okay, the first thing we're gonna do is I'm gonna make a file called lists.py. So lists.py. So if you are in VS Code, I'm not going to do this in VS Code tonight. Like I said, we're going to start to move away from, we're going to start to try to mentally separate the concept away from the tool. And as you're picking up your skills with VS Code, ask your questions if you're running into problems. But all you got to do is open up your Visual Studio Code and go ahead and create a file wherever you want it to be created. Hopefully we're at that point. And let me know if you run into any troubles doing that. If you're trying to copy exactly what I'm trying to do here, I don't direct, you know what? I'm just gonna open up in VS Code. Just to one more week. I'll stick with VS Code. So I'll do code, and I'll type in lists.py. So what this will do, you probably never seen me do this yet. Yes, Gene, I love it. I love it actually. Yes, touch. We can touch it first. So touch, and the name of the file we want, lists.py. There we go. What's up, best noob? Hello. How you doing? So touch list.py, what does touch do? We're practicing those Linux commands. It creates an empty file for us. You do not have to type that if you're in REPL. I'll tell you if you're in REPL when you need to start doing stuff. You don't need to start doing anything if you're in REPL, only if you're on your command line. So we touched the file. Now we're gonna open it in VS Code, and I'm gonna do code, list.py, and it's gonna open up VS Code for me. It's gonna open up that empty file that we just created. I'm good, best noob. Hello. I'm glad you're doing good too. Oh yes, Windows, it's echo. Yeah, it's like echo something to create a new file. But again, you can also create that new file right here in VS Code. So make sure you have this top Explorer selected and just bring your mouse down. See, now I need to open up a folder. I'll just open up this folder. And you can create a new file right here instead. later. All right, let's modify this file. Let's learn about lists a little bit. So the way that you make a list is the way we're using some of those data types before is we did a lot of examples where we were assigning that data type to a variable. We can do the same thing with a list, because these are data types as well. So I can type in something like a variable name. I'm going to call it our list. So that's the name of our variable, and it's going to be equal to, and remember, the thing that we're learning right now is a list, and we said in the we said right here that lists are defined by having values between square brackets. So let's get those square brackets in there, which we just did. And again, that helps you kind of visualize that this is a collection of data. Those kind of square brackets, I think, visually help you see that this is everything inside of here is a collection of something. So you can put any data type in here. And each item in this list, remember, everything in the list, each individual element is called an item. They are separated by commas. So let's say, actually, to make it a little simpler, let's just start with something simple, which is a common first list. Names. Maybe we just want a list of names. So and actually, I'll copy you all's names. We'll copy people's names from the chat. So mgene718 is going to be the first name that's in here. And again, we're going to make it that's a cheer. We're gonna make it the data type string. So that's one item. We have one item in here. So mgene, the string mgene is here, and that's a single item. So this is now a valid list. It's valid. Your number, mgene, I hate to burst your bubble. You are not number one, and we're going to learn that very shortly. You are actually number 0. I'm sorry, but you're number 1 in my book. I promise you. You're number 1 in my book. But you put a comma to add names. So we'll add Chelsea's new, so we will add Chelsea in here as well. Let's copy. Chelsea is the second person here. The second item in our list is Chelsea Carter. Again, a single item makes this a valid list. Actually, with no items, it's actually a valid list. Like, this is a valid list. Our list equals. This right here is actually a valid list. It's an empty list. This is that 0 value we were talking about. So the 0 value for a list is essentially this thing right here. But we'll delete that. And so let's put in 1 or 2 more people in here. Let's grab Sean, because you're also number 1. I'm just grabbing the names that I see immediately that pop out to me. I feel like it'll be faster if I just type these in. And let's do one more. Heezy L. I like that. Yeah, we'll just type it. Heezy L. Okay. And I'll close this. All right, so we have a list of names here, and they're separated by commas. So each of these is an item in the list, a separate item in the list. And remember, this list is ordered. So let's first see what this looks like if we're going to print this out. So let's actually print the list and see what it looks like when you put it out to the console. And we're going to run this. So if you're in REPL, you can go ahead and hit that run button. Python 3 list.py, and look at that. It looks exactly the same. Exactly what we typed in, exactly the same. But again, it is just a list. It's a collection of it's an ordered collection. It's mutable, it's changeable. So now that we can see this coming, now that we can see what it is, now let's understand the caveats of working with it and what you can do with it, and kind of why it's good. So the first thing is that we only put things of type string here, but you can put all other data types in here as well. So this can have any number of things, but they don't have to be names. I can put the number 34 in here. I can put, so this is, what kind of type is this? This is an integer. I can put in false here. That's an item as well. So I can put a Boolean there. And let's try a 12.45, which is of type float here. And this is still valid. This is still valid in Python. Now, while this is valid in Python, statically typed languages, this may not be available to you. Like in Go, you cannot do what I'm doing right here. With this, there are ways to achieve a similar type of structure that has multiple things, but you can do this in you can do this in all dynamic languages. You can kind of combine the data types that are in here. Now, notice that I want you to notice a few things. When we print this out, no matter how many times we print this out, it's going to print out the same exact way. It's going to print out the same way that it's put in here. Again, that the reason we bolded the word ordered is because it is ordered. It's 100% ordered, and it's going to stay that way. The order does in fact matter. Now, how many items do we have in this thing? Let's count them up. Let's practice our counting. We have one item. And how do you know where an item stops? Again, look for the comma. That's how you know where an item stops. So like in here, I can have spaces and I can have a whole thing in here, but this is one thing. Look for those commas. That's where the separation lies. Actually, even if there was a comma in here, this would still be one thing. Look for the commas that are outside of quotes. That's where the separation is. So we have one item here. We have two items here. We have three items here. We have four items here. We have 5 items, 6 items, 7 items in this list. All right. And again, this is a list. I do want you to submit the name array to your memory. Array is pretty important, and it's what it's going to be called in a lot of languages. But and it's so interesting. This is an array, but in Python it's a list. We're not going to get too deep. We are going to get a little deep when we get to the Go part. I'm going to wait till we get to the Go part to dive a little bit deeper. I don't think you need to know that right now to kind of understand how this data type kind of works. So now we have a structure of data all together. So maybe in a program, there's a common paradigm. We counted that thing manually, but you may have thousands or tens of thousands of things in this list. And you wouldn't want to count that manually. So pretty much all languages provide a method or a way for you to find out the amount of items in either an object or some type of data structure. And so that in Python, and it's either I deal with so many languages, either .length or length, but I can do let's do print. Let's see, I think it's len in Python. Names, I think this will do it. So len, which is short for length, and it returns the number of items in a container. This list is the container. So I have this list here. If I want to find out how many things are in here, I can use len and open and close parentheses and put with the thing that I want to find out the length of inside of it. So I'm gonna save this and I'm gonna run it. And it says we have 7 items. I don't remember how many we said we had. Maybe I counted it wrong. But we have 1, 2, 3, 4, 5, 6, 7. We have 7 items in this list. So len is a great way. Like I said, every language has a paradigm for this. Some depending on the language, you can do this for things like words as well. You can find out how many characters are in the letter because of the way that it handles those things. In some languages, it's an object. Some languages, just the way different languages handle things, that may work. But for right now, if you want to know how long a list is or an array, you can find out using the length. You can find out by checking its length. And length is the term that most languages use to kind of find that. So even in Go, it may be the syntax is going to be different for checking it, but it's what you're doing is still checking the length of what you're finding. Okay. When I have a capital P in print, I get a name error. Yes, correct. Slime, that's good. I like people are exploring. You cannot capitalize these things. They are case specific. This is not the same thing as this. And again, we learned out a little bit about why that might be when we talked about encoding and ASCII and things like that, bits and bytes and binary. But yes, they must be exactly as they are written in the language. So you must do the lowercase p. Okay, so this is great. We can find out how long something is. And so if we add in another, let's say we add in another item here and we try to check that, it's 8. we added a single item, it's 8. So it always is going to check the length of this. But just to, again, mess around, see what happens if you forget to put a comma in between. Let's see what happens when the list isn't properly written and we get this error. We do get an invalid syntax error. So we're gonna talk about errors at the end, and maybe we should move that up. Maybe we might actually split errors up in between each of the sessions, and maybe make that last one another algorithm session. But it says invalid syntax. Syntax is kind of the structure and the way that you write the language, and so missing the comma is invalid structure for the language. So you need to go ahead and put that comma back in. Those commas are very important in this case. But yeah, syntax, just like grammar, you got to get it right. But there are rules here for this. Okay. So let me actually make sure I'm not going to, actually I am going too far past. I didn't realize there was a slide here for this. This is great. Let's go through all these things. So we did I showed you the first one. Oops. I showed you that you could have an empty list. That's that empty value. So I can set a variable called our list, and I could set it to an empty value. And maybe let's do that and see what that looks like when we try to print it out. So we try to print names, and let's try to set up another one called empty list equals this. And now instead of printing the length, actually we'll still print the length. Let's also print empty list. Let's print that. And you can see here, oh, come on, go away. The same way that up top it printed out the full kind of thing, it prints out just the brackets to show you that it's still a list and that we're all good. So that is an empty list. Defining a list with values is what we just did. And so, you can put any items in there, any number of items in there as well. Now, this is why the order matters. You can reference a single item in the list. You can reference an exact item in this list. So let's take a look at that. It's by calling the variable name and using the square brackets and using its numbered into its index location. So let's talk about that really quick. Arrays and lists and collections of data like this in languages are something called zero indexed. And this just means that the very first item in the list is at the 0 place rather than the 1 place. So MG, and like we said, you're number 1 to us, but right here you are in the zeros place. This is 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 8. We have 8 in here. So there are 8 items, or seven items. What is it in that 7? How many things are in here? 7, 6, 5, 4, 3, 2, 1, 0. Yes. So it'll go from 0 to the number. So 8 items, but their places only exist from 0 to 7. Those are the only valid numbers here. So let's take a look at what that looks like. So we're going to remove the length here, and we're going to print out. We're going to remove both of these, and we're going to print. And this is kind of confusing. The very first time I did this, I had a lot of trouble doing this. But if we want to reference a single item, you call it by its location. Again, this is why the order matters. The order does not change. So I can always reference mgene. Mgene is at names 0, and so if I print names 0, it should give us mgene. Wow. Oh wait, I don't know where that came from. And there we go. It prints out just mgene, and it prints out just the string mgene, and ignores everything else in the list. It pulled that data out. So what would we want to do? What could we do if we wanted to print out Sean from LA? What number would we need to change this to print out Sean instead of mgene? We got 3, we got 2, we got 3. Print names 2. So let's try that. So let's put 2 in there and let's see what we get, and then we'll work through it. I'm gonna run it, and that gives us Chelsea Carter. Why does it give us Chelsea Carter? Let's count on up. Starts at 0. So 0, 1, 2. So 2 gives us Chelsea Carter. Sean gives us 3. So let's try 3 now. Off by 1 errors are a huge problem in programming. It's almost always an off by 1 error. It's frequently a problem, but 3 would give us Sean from LA. Yeah, so basically it's actual numbered place -1, but you just need to start from the beginning, count from 0. Takes practice. It definitely takes practice. Like it's unintuitive. It's unintuitive to us. So you're not used to thinking in terms of the way that a computer works. It actually makes a lot of sense. It actually makes a ton of sense when you dive a little deeper into it. I think I included a YouTube video kind of explaining a little bit, but it actually, I think I pulled that one specifically because the person who was explaining it did a bunch of stuff with C++ that I thought was going to detract from understanding why it starts at the 0 index. But yeah, so if we wanted to do the very last item, we could go, we know there's 8 things here. So 0, 1, 2, 3, 4, 5, 6, 7. Oh, wait, 6, 7. So we call 7. Let's change that to 7. And we get the last item in the list. Now I want to show you something fancier. And you already called it easy. You can also do negative numbers in here. So you can actually go backwards. So if I call 0, that gives me MGene. It gives me 0, always gives you the first item in the list. So that gives MGene. But if I do -1, it does in fact start to loop backwards through the list. So it does in fact give us this. And so if I do -2, it'll actually give us false. And I've heard a lot of people be very confused by this because in the reverse order, it's not 0 indexed. And well, it's not 0 indexed if you think about it. Like a lot of people think it's just doing the list backwards, and it's not just doing the list backwards. It's actually doing the list from the 0 spot still. So this is always 0. This is always gonna be 0. And if you add 1, you go here, but if you -1, you go all the way back to the other end. So if we do -2, we will get the next one down, which is in fact false. And so the thing is, you can only do it once through though. I don't think you can do it twice. Like I think if I do -8, I think it'll give me MGene, I think. But if I do -9, it will not, I don't think it'll work. And so it gives us an index out of range. And this is very important. This is why the amount of items in the list matters. You cannot try to reference something that doesn't exist. So if we try to even look for just the number 9, if we try to look for names 9, there are only 8 items in this list. And the index only goes from 0 to 7. 9 does not exist. 8 doesn't even exist. So if you try to run this, and you'll get this list index is out of range. The number is larger than the amount of available options. You will run into this problem very often when we are doing algorithms. You're going to run into this all the time. Index out of range is a common thing, but that is what it is. You can only call a number that actually exists. All right, any questions about that so far? There's still more things on this list, but so far, any questions about that? Oh, if your list is different, yeah. If your list is different, then you probably, yeah, you can go off of that. That'll do it for sure. Can I do 7 + 1? Oh, good question. So you mean like in here? Oh, like here? Like 7. That's a great question. I see. Oh man, the curiosity. And so this would be index 8. And let's actually do it for something that might be valid. So let's do 1 + 1. So this would be number 2, which would be 0, 1, 2. So if this works, this will give us Chelsea Carter. And wait, can't open. Am I missing something? Can't open file, list P, no such file or directory. Oh, whoops. I was like, that doesn't look like a Python error, and I knew this would work. So yeah, so Chelsea Carter, it does. You can in fact do some math inside of here, and this is great because you can do things like if you're not sure how long something is, and you want to maybe pull the last item, you can do stuff like this, like length. So we know that this, so length of names equals len names. So the length of this, however many items in here is gonna be, was it 8 or 9? So it'll run this and it'll set it to the value of length of name. So I'm gonna remove this really quick and I'm gonna print that out. We're gonna check how long names is. It's gonna save that value to a variable called length of names, and we're gonna print that out so we can see how many, so we can see how long it is. All right, so 8. It has 8 items in it. We know that it has 8 items in it. This variable is a number. The look at that. The type is an integer, so it is a number. So we can use that variable. We can use it like a number. So I could also do like print names. And we know that in these square brackets, we know that a number goes in there. So a number could be length of names. That's a number that's equal to 8. And so if we print that, we're gonna get an out of range. Why are we gonna get an out of range? Because although there are 8 items in here, it only goes up to 7. It goes from 0 to 7. And this right here equals 8. So you can just do a -1 in here. And this will always reference the last item in the list. So this is a common thing to do as well. Check the length and subtract 1, and that'll always print out the last item in the array or the list. And you can see that that's this item here. So just another way that you can use the length. Again, that is just showing it to you now. It'll come up again. It will come up again that we actually have to use it. So I think if I show it to you now and give you some time to marinate on it, it may click once we get to that point. But just know that this is a number actually, and you can add and subtract in here. So that was a great question from the greatest Rob. All right, does Python have a garbage collector? Well, yes, I think all interpreted languages have a garbage collection. I'm pretty sure. So yes. Okay, so the next thing we are gonna do, let's see what else is in here. Now let's learn about doing some list methods. Actually, what happened to my music? Oh, a new song is just starting. Okay, some list methods. So the same way that we were able to, actually first, before we get to some list methods, let's go to this next one, which is changing an item in a list. Let's go back because it's very important. These lists are mutable. A list is mutable. It can be changed. The items in it can be changed. The order stays the same. You can change the order of things, but the order remains the same unless otherwise, unless you otherwise tell the program to change it. But the items in there can be changed. So how would you do something like that? The way that you do that is because you can reference an individual item. I can now say names. Maybe we want to change number 5 to someone else's name. So we can say names, and this is in the zeros ones place, so this is in the 1 index spot. So we can say names 1, which references 5, is now equal to something else. So let's grab someone else's name, Mickey 171. Mickey, oh wait, is there no music? There should be music. If there's not, I'm sorry. I've been listening to music the whole time and I've been holding out on you. Mickey 171. And so this will now, if I now print names again, names will now have changed. So let's see what this looks like. So now we have MG in the first spot, but now the second item is now changed to Mickey 171. So you can change up individual items in the list by calling same. I can't focus without the music either. It's actually become pretty bad at work. Like I had to mess with my mixer and stuff so that I could hear my music only and not it pipe through to my Zoom channels and stuff. I need it on. It's really annoying. Yes. Is Python lists really arrays? Yes, it is. It is really an array. I'm not sure why Python calls them lists. To be honest, it is an array. I think an array underpins. I think a real array underpins this and a number of other data types that they have. But yes, it is an array. So can you explain a little bit about how the computer is interpreting that change? How deep do you want me to go here? Do you mean how the computer is finding the so the computer basically is these are this information, they're actually pointers in memory. So like, remember that RAM we were talking about? There's a little bit of memory that holds this information. There's a reference to this spot, and when we do this, we're basically saying, hey, go to that spot in memory and remove the underlying value and put this one in. Now this works differently in some languages. Some languages like Go, arrays work way different, substantially different, and something like this is actually called a slice in Go, and it actually instead of replacing that spot in memory, it actually creates a whole new spot in memory and fills out everything else, and then removes the old spot in memory. It's kind of confusing. Like I said, new value replacing that value, or remembering the original value as well. Great question. Now, in the case that we just did here, it actually changed the complete value. So variables, we learned, can change. Variables themselves can be changed. Whenever you see an equal sign, that is an assignment operator. We are assigning the thing that is on that, like we're assigning the value of what's on the right to the thing that's on the left. So whenever you see that that equal sign, a single equal sign, that is a permanent change. That is a it's a change that's actually happening to that thing. It is not just a temporary thing. So we are assigning that value. So that's why when we print out names, it is actually completely changed. It's not only happening on this line. This array is something completely different. It is actually this array now. So that is actually a great question. This is an excellent question. It does in fact make this a permanent change. So I mean, there are ways you can manipulate data without changing the underlying thing, but we did in fact change that here. Like I could do, like if I did something like if I just want to do like print names 1 plus 5, and then print names again. This line up here is going to add 5 to 5, so it's going to print out 10 here, but it's not actually changing the value of this because I'm not setting it equal to anything. I'm not assigning that value to anything. I'm not catching that value. So if I run this, it's going to print 10. So it actually, it used that data, but it didn't change the underlying value at all because there's no equal sign. So good. That's actually a really good question. All right, multiple basically the same thing. Yes, NumPy is a pretty cool package. We're actually going to probably do a little bit of NumPy stuff towards the end of this, for sure. Okay, cool. 750, we're there. And then I think the last thing. The last two things were just things that we can do to the list, methods that we can perform to the list, similar to those cool things that we were able to do to the strings and the other data types. We can do things like that to our data structures as well. These are data types as well. It's very confusing I just know that someone's going to message me about this, but we can do the same thing. So we have some options, and we can go over to W3 Schools again to see those, but I just want to give you some of the simple ones. So we learned how to change an item in the list, but what if you want to add an item to the list? If you already made a list, how do you get a new item into the list? And then how do you delete that? So let's just see that really quick. So we already have a list here. Let's actually make this list shorter. Let's remove all the extras from it, so we can see the whole thing. We don't need any of this. We'll save this list. All right, and names is here. Now, how do you add to this? We already set it up. Maybe when we did some stuff to it. How do we add to this list? The way that you do it is you use a method called append. And so you can do the name of the list dot append, and it will and then the thing that you want to append, and it will add it to the end. So append, the word append means kind of tacking something on at the end. So if we print names the first time, I'm going to now do names dot append. And I'm going to put a new person's name in here, and let's do Coderholic. We'll do Coderholic, and then we'll print out names again so we can see the change. Okay. So up here, we made a list. It's got 4 people's names in there. We printed out, though we're going to print it out so we can see it. We're going to add a name to it with the append method, and then we're going to print it out again. So let's try that. Let's clear this. Let's run it. So first time, looks like it has the 4 that we put. And then after we append, look at that. It now has Coderholic on there. I think I saw someone, the greatest Rob, I like that. You used the that makes sense to try to use. We know that we can add a placeholder spot, or that we can refer to a spot in the array or in the list here. Can we assign a value to that? So let's actually try that out and see. So instead of adding Coderholic this way, let's try doing, you did 9, but there's 0, 1, 2, 3 people here, 3 things here. But maybe an easier way to try to do this, maybe we could go, well, first we'll put the number and then we'll do the easier way. So maybe let's try doing names 0, 1, 2, 3, 4 equals Coderholic. Let's see if this works. Let's see. We'll print it and it doesn't work. So it doesn't work because it can't change a value in the list if the value doesn't already exist. So what it's doing is it's trying to basically open up the space that this thing exists at, and it's trying to put this information in there, but it doesn't exist, so you can't open it up, so you can't add it. You're unable to add it this way, even though it makes sense that you would be able to do it. Do names plus Coderholic 2? Great question. Let's try that too. So names equals names plus Coderholic. I like that. I like that we're trying to do things. I think we saw a little bit that we could add together. So you're trying to concatenate this. You're trying to concatenate the list and the string basically. So let's see what happens here when we run this. And you cannot do that out of the box. Why? So although we're talking about data structures, I said these are also non-primitive data types. If names is of data type list, or if it's a data type list, and we want to be able to work with it with a string, it says basically down here, cannot concatenate list and a string. What can we do? What can we try to do? It might not work, but I'm pretty sure it'll work. What can we do to try to make 2 data types kind of work together? What can we do here? What can we use that we learned last time about data types? This is exciting. But keep asking the exploratory questions. We're going to explore. I love it. I love it. I actually wouldn't have tried to do this, but it makes perfect sense why you would try that. But yes, we can try to typecast it. We can try to make it into a string. We're going to try to get Python to turn this into a string. And the way that we do that is simply with this string method, str function. And let's see if this works. So now we're going to try to cast this data type here into this data type. And we'll print it out, and almost gives us our intended function. But this makes sense of what it does. What did we say about the word concatenation? Concatenation means it is the act of putting strings together end to end. So it turned this into a string, which this is just a string now, and then it put Coderholic right up at the end. So it does not include it. It does not include it to that collection of data, but it will try to print it out. So that is actually, I mean, that's a very reasonable guess to think that you could do this. It actually makes sense. So that's pretty cool. I'm glad someone asked that. Just to be clear, list, doubly linked lists, arrays, vectors are very different. Might seem like the same, giving listiness appearance. Yes, absolutely. B Bytes back. Yes, we are going to get into all of that, but that's great. Okay, what if you names equals names plus lists? Oh, adverse. Hey, here we go. I love it. Come on, let's do it. So we say names plus. So instead of converting this to a string, we're going to convert this to a list. Now, you know, I actually don't know if this is going to work. I doubt it's going to work. The reason why I doubt it's going to work is because the plus is going to attempt to concatenate strings. And because neither one of these are strings, I have a feeling it's not going to work at all. But let's see. I think this is great. Exploratory And oh baby, that is great. Now I'll tell you exactly what just happened. This is interesting. I didn't know this was gonna happen. All right, so we got MG, we got all the people we had before, but then we have CODERHOLIC. This is great. So what it did is it added each letter of Coderholic as its own item in the list. So it did add to the list. It did in fact add to the list, but it added each of the items in here. So it broke it all down. So I'm actually now interested about some other things, but the list to cast to a list, it does in fact do that. So if you ever need to break up the letters of a word, you can simply just do that. Like if you do, let's not print this or this, and let's simply print list of, of Aaron. It will spit out, wow. It will spit out a list of the characters in my name. I don't know why I clicked that. And that's what list will do. I forgot list did that in Python, to be honest with you. So it did work. It worked, not as intended, but it did in fact work. That's pretty dope. If you just put a brackets around Coderholic, it works too. Oh, so like if you, so if you make Coderholic a list itself, that is also great. That's great. So that's what you're doing here. Coderholic is not, yeah. So basically what you're doing here is you're adding two lists together. Yes, that is something that you can do. So even if Coderholic, so we'll do this really quick. Python 3. So you can in fact add two lists together, which we did here. So you can't add a list and a string, but you can add two actual lists together. And so if this had more items in here, like if we add someone else's name, let's go B bytes back. Let's look at the last one. And I need to put that in. If I add B bytes back, I can add both of them. So I can in fact add two lists together, and that's something I'm putting here. So that's good. That is good. I love it. I love it. Talk about being able to shoot yourself in the foot. Yep. Okay. So if you try length of name, it will give you 9 or so. So if we actually do length, let's do length in both times. So let's print out names. Let's print out the length of names up top, so we can see how long names is. And let's copy this, and let's also do it at the bottom. Let's do it twice. So we're gonna print out the first list. We're gonna see how long it is. We are going to add to it, which, we started out with the append method and we explored our other options, and we're gonna print the new one out and see how long that is. So let's clear this. And so first time it has 4 items in it. But again, remember, what are the indexes? 0, 1, 2, and 3. It only goes up to 3. And then in the bottom one, we added 2 to it. So now there are 6, but it's 0, 1, 2, 3, 4, and 5. Dope. We are very smart now. Everyone is a genius. I was so excited once I started to get lists and arrays and start to understand those concepts at first, because like that's when it felt like I was doing something. I was like, oh, I can, I have a shopping list. I can pick some stuff out. So yeah, it's kind of cool that you can put all of your shopping. You are almost ready to be able to write your own shopping list app, to be 100% honest with you. Almost. Okay. So, and then the last thing is, how do you delete items from the list? There are 2 things here. There's actually one more, I think, but there's a pop method that's like the append, or there's a remove method. I now wonder, I actually don't know if the minus works, but let's find out. I kind of like this. What happens if, no, let's start with the pop. Pop and remove. Why are there 2 different options? There are 2 different options because one of them will remove the item, but also return the value to you. So it'll say, all right, Heziel, I'm gonna get rid of you, but I'm also going to give that information back to the user, and the other one will not. So let's see how that works. And pop will always remove the last item by default, I believe, unless you can specify which one. because like I think you can just do like let's print names, and then let's do names dot pop, and I think if I hover over it, it'll tell me. I didn't. I think I can just do names dot pop, and I can print names again. And I think this will actually work. And I think it'll just remove the last item from the list. So let's clear this and let's run it. As you all can see, I like Python, but I don't do that much with it. So so it ran it. It removed the very last item, and it and when so now like pop actually you don't these methods you don't actually need to save the value. I don't need to do like I can't actually do names equals names dot pop. I don't need to assign it a value. That can be pretty confusing. It actually goes through and actually modifies that thing. So it pops that item off, which I think save to an output. Let me see, output equals names.pop. I think pop does return the value, and I can print output. I think that's how this works. And I think removes is the one you do have to set it equal to something. I think, or opposite. Let's see. Let's find out. All right, so I popped off the last item and I saved that to the value output. And right here, you can see if I print out output, it is in fact easy L. But let's try remove now. I actually think remove needs I think it needs an index. I'm gonna try to run it as is with the remove command, which I don't think it works. I think you have to tell it what to remove. So maybe I want to say remove the first item. So maybe I want to remove mgene. And I don't think this is gonna work either. Correct. But I actually think I have to give it the value. I don't even think I can give it the index. Remove X. I think I have to actually give it mgene. I never use the remove to be honest. I don't use it often. We'll find out in a second. Yes, but it does not return the value. That's the difference. I tried to catch the value of this and it did not catch the value. It did remove mgene, as you can see here, which is interesting that it allowed me to run it like this. Very interesting actually. But it does not return the value to you, so you can't capture that. Yeah, there we go. Okay, so that didn't remove. So pop will pop off the item and return the value. And I think you can also do the value as well. So if I do like, I'm gonna do output again, so you can see it. I think you can also pop a specific thing off of the list, which is, but this one's actually the index. So if I want to pop off mgene, I actually have to do 0, and that will pull mgene from the list. So you can add with the append method, or you can add with adding another list to it. You can subtract using the pop or remove methods. Pop returns the value that you're popping off, and remove does not. And when you're using remove, you need to know the actual item rather than the index, which is interesting. All right. Hardest part of programming, in my opinion, the hardest part of programming, in my opinion, is learning to you're learning to think differently. The act of learning how to program is not actually that difficult. I think the reason why it's so difficult is because you're learning how to solve problems in the way that like humans don't solve problems, I think, in the way that you're trying to use computers to solve them. So like you're approaching problems differently, like way differently than I think you're normally taught to approach problems in your life. I think that's the hardest part. And I think it takes so much time to kind of reprogram how you think. And then it's almost like if you were trying to learn how to solve problems that like I know how to learn how to solve problems. The computer has a set of rules, it has a way of thinking, it has very specific things it can do. And you're having to step into that world and figure out how to use these tools available to you to get the computer to do what it does. So I think that's the hardest part. Like, again, people are usually overwhelmed with the syntax and stuff. I like, yes, that stuff adds to the confusion, but learning the language is relatively simple. Like learning, you know, functions versus like how to make a variable versus these different data types. Yeah, it takes a little bit, but like you'll get that stuff. It is the change in your mental thinking model, I think is the hard part, for sure. Yeah, understanding which tools to use, libraries and methods. Yeah, because it's so hard to learn which one of those things to use and when to use what, until you start to contextualize the scope of what the computer can do and like what you can do. Like when you're first learning, you don't even know what you're capable of. You don't even know what code can do. And I think that's why I get really frustrated when people say, oh, you want to learn how to code, just go build a project. You can't just go build a project. Like you don't know what you don't know what you can do with code. Like you don't understand what you can do with it yet. And I don't know, it's hard to get there. It takes some time to get there. And I understand why people throw that stuff out there, like, because it is true. It is true that like the best way to kind of learn this stuff is to just try stuff and to start to build things so that you can run into problems and start to like pick up these things. But you can't do that until, like, I wish people I'm working on it. I think it's always gonna be a problem because like I always have trouble pointing to people to like, these are the projects that you should be doing, or these are the things that you should try next, or you should go build this. It's a problem. I think it's a huge problem, to be honest. Well, we're gonna figure it out though. We're gonna find a way to tackle exactly that. But yeah, you don't know what a computer can do. You don't know what coding language can do. That like, even that goes into, again, when I said I know a lot of people who tried to go from who learned something like JavaScript or Python first and decided they wanted to or they got a job or something and they were moving into a statically typed language with some more rules and stuff, like a compiled language, and they were overwhelmed by the, like, yes, the increased complexity also means you have an increased amount of things you can do. Like, yeah, it's more complex. You have to do more things manually. You have to handle things differently. But that also means you're able to, you have the freedom a little more to do honestly bigger and better things a lot of the time. So, with more responsibility comes more freedom, comes more responsibility. So yeah. All right, so that is lists for us. We're through it. I think once you understand lists, arrays, the rest of these besides dictionaries are going to be fairly easy to wrap your head around. Dictionaries might be the only one that's confusing, but once you knock lists out of the way, and again, I don't expect you to be a pro at lists right now, but now you know there's a way to identify a collection of data, of data types, and they're separated by a comma, and I can reference those things and I can change them. They can be changed. We know that the order matters. We know that that there's zero index, so you'll forget that. You'll forget it 10 times, but you'll forget it and you'll be like, oh shoot, I need to change that. I need to subtract 1 because it starts at 0. But it'll come. So now let's move on to the next one. Is dictionaries next? It is. That's weird. I ordered this wrong, but whatever. Dictionary is next. The other two will be pretty easy after this. I think the answer is very dismissive. It is. Even to this day, like, I don't even know what I want to go build sometimes. People are like, what are you passionate about? Bro, I don't even know what I can do. How am I gonna be passionate build something that makes you tick? Bro, that doesn't make any sense to me. And like, I get it. I do get it. Once you're there, it seems so enlightening. It seems like the thing to say. It's like, oh, what do you love? Like, go build that. So it's like, all right. Like, I love cars. I can't just, if I ask the mechanic, how do I get into being able to build race cars or something, he's like, just go build one. I'm like, man, I don't even know where to start, man. Like, I don't know, but it is dismissive. I think it's frustrating. And I think people mean well. I really do think people mean well. And that's what's so frustrating about it. So I feel like it's something we got to solve now. But cool, dictionaries, key and value stores. that's what they are. So dictionaries are real. I really want you to be thinking about real dictionaries in real life. No, you are not looking up you know, the definition of words, but a dictionary is a key and a value store. The key is the word you're looking for. So you crack open that dictionary, you go to the word tonight. You see tonight right here. You want to know what the word tonight means. You go to that T section, you find tonight. That is the key. And then it has an associated value with it, which is whatever the definition of tonight is. It is, sure. Actually, now we gotta look up the definition of tonight. I always am interested at words like that are simple words. I want to know what the actual definition of. The adverb tonight. On the present or approaching evening or nighttime. Are you doing anything tonight? Yes, we are. We are educated people. Or it's the noun, which is tonight, the evening or night of the present day. Tonight, today, not tomorrow, not yesterday, tonight. I love it. Oh man, I'm gonna learn definitions of very simple words, and every time I say those words, I'm gonna say the definition afterwards, and people are gonna think I'm the smartest person ever. But that is what dictionaries are in Python. They're key value stores. It's like a map. So dictionaries in Python are in unordered. We know the lists are ordered. These are an unordered collection of data values used to store data values like a map. Dictionaries holds keys and values, a key and its value. So let's get going with dictionary. So how do we define an empty dictionary? You should be thinking about little curly braces here for dictionaries. And so every language does not have a dictionary. Other languages are called other things like maps. They're called different things in different languages. But yes, this is the concept of dictionaries, I think, is going to be fine here, and we're going to expand on the differences to other languages as we move through the course. But let's create some dictionaries. So let's create a new file over here. We've done enough with our list here. Let's create a new one, new file, dictionary.py. Whenever you're teaching dictionaries in Python, it gets kind of tough. Because you'll see in a second. You have to enunciate. You'll see why. So whenever you want to see I'm going to type out the full word dictionary because I don't want to get banned. And our empty dictionary is going to be our little curly braces right there. So that'll make an empty dictionary. And there we go. This is why it gets tough. You have to enunciate because usually people cut this down and refer to these as dicts. So gotta make sure you say that T, gotta make sure you include the T in there. I'm not being lewd. These are dicts. Perfect. We got that out of the way. Now we can be adults about this and go on with our day. So our dictionary right here this is an empty dictionary, and you can in fact print this out. So let's print it out and see what the empty value of this looks like. Save it. Come on, bring it up. Python 3. What do we call this? Dictionaries. Okay, just like no different than the list, it prints out the kind of structure that holds it. I do really like that languages use these different methods of visual representation. I mean, I know underlying it works for them, but you know, it becomes pretty easy as you're working through things to easily identify what something is without having to, you know, like highlight it or, you know, check the data type of it or something. But it is dictionary. This is empty. These dicks. I mean, yeah, I mean, we are working on these dictionaries. So we have an empty dictionary. Now we can define dictionary values the same way that we define list values. So they are separated by a comma, but these are key and value stores, so it looks a little differently. So we have a key here, which is like name, and the key and the value are separated by a colon. So you see the key, colon, value, comma, key, colon, value, comma. And so let's do exactly that. And so let's I don't know, what do we want to make a dictionary of? I feel like name and age is pretty boring. What do we want to what do we make a dictionary of? What do we want to do? I don't got anything. Let's I'll give you a chance to throw something out. If not, I'll just pick something. Best rappers. Okay. And so maybe we'll do like categories of rap, because like the key's got to be something, and then we'll do the value. So maybe we want to do like the best Southern rapper. All right. And just keep it simple. I'm just have to put Outkast over here. This is not a democracy. This is a dictatorship. And so maybe we want to do best mumble rappers, right? The mumble category. The best of mumble rapper. I can't put Wayne in there. I can't. I'm gonna put Migos in there. Now these are not my true feelings. I'm just throwing some stuff out there. We're having a little fun. We don't need to start a rapper war. Oh, dictatorship. That's good. That's perfect. I missed that one. I definitely missed that opportunity to do that. A mumble rapper is Migos, sure. Maybe we want to do best conscious rapper. And I don't think that's how you spell conscious. This is not a spelling course. This is simply a coding course. And remember, we need to put that colon there. And there are a lot of conscious rappers out there. Look, don't argue with me. I'm just gonna put Cole. I'm gonna put J. Cole there. Great, excellent. So we have 3 things. We don't need more than 3. We're just having fun. And so maybe let's call this, best rapper categories or something. You can call this whatever you want. Again, we're still making this is a variable. You can call this whatever you want. So maybe I can change it to that just to make it a little more descriptive. So best Southern rapper, even though it's not a one rapper. Best mumble rapper, conscious rapper. Okay. Simple. We made different items. So how many items do you think that we have here? And can we use the same thing that we did before to find out? So how many items do we have? It may look like we have a bunch because there are a bunch of words here, but again, a key and a value makes up one item in a dictionary. So this is a key, value. So that's one item. So we have 1, 2, and 3, but will length work? Will it work? Length, best rapper category. Save it, run it. It does work. It tells us we have 3 items here. Excellent. That's a good one, Sean. You're thinking. I can tell your mind is churning through the index values. There are 3 items here. If these were indexable, it would go from 0 to 2. You would in fact be correct. But there are 3 items here. Now, let's see if we can do some of the same stuff we did before. So maybe let's just see if we can print out the very first item here. Let's just check it out real quick. And the first item is 0. Let's try to print that. And oh no. Oh wait, actually. Well, let's do it right first. I give you a precursor. Oh no, we are unable to see the best rapper at the category 0, which will be the first spot of the dictionary. We are unable to call that spot. The reason that we cannot do that is because dictionaries are what? They are unordered. They're unordered. They are not ordered. So when things are ordered, that's when you can call them at their index location. The location matters for things that are ordered. But if they're unordered, if the order doesn't matter, if the order isn't saved, how can we call something at its place? So we are unable to use that indexed value to be able to call, to be able to pick out a dictionary item. So how do we reference a dictionary item then? The way we do it is we reference it at the key instead. So if I want to find out, the value of one of the items, I need to know the key. And so I'll call, our dictionary at age or whatever. So if we want to find out the best mumble rapper, we check the mumble category. We call the mumble category, and what do we think this will give us? This will give us Migos. the greatest mumble rappers of all time. They dropped a new song pretty recently. It's pretty decent. It's all right. But it gives us Migos. So again, keys and values. So you know, that's just like we looked up in an actual dictionary. It's like we looked up the word, maybe we wanted to look up the word mumble, and we got the value of it. So we got the value back. We got the definition of mumble basically back. So that's how we reference that. So we could also do, you know, any of the other keys. But what happens if you type in a key that's not there? You know, this key does not exist. What happens? We get a key error. It's actually a key error. I didn't know you can actually get a key error. It's pretty cool. But it does not exist. It's saying, hey, I looked for this key, but I could not find that or a value. Your next question might be, what happens if a key's there but no value? So maybe we're not sure who the best Southern rapper is. Can we do something like this? And we look for the key Southern. And invalid syntax. Why is there invalid syntax? Because the dictionary does, in fact, each of these items does need a key and a value, but the value can be empty. The key, I don't think, can be empty, but the value can be empty. So I can just do an empty space like this. And it does, in fact, print nothing, but it does not give us an error. These keys also don't have to be strings. They can be numbers as well, or any other data type. They can be true or false value. They can be booleans, floats, whatever. Just like a list. So that doesn't matter. It does matter in our case because 2 is not the best Southern rapper. I don't even know what that means. Stupid. But yeah, key and the pair. Okay. This is not like classes. It's not like classes. You know what? Kinda, because I only say this because Go is not an object-oriented language, but it has object-oriented paradigms that you can do using things called structs. And structs are kind of dictionaries. It's kind of loose, but yeah. You can see it by doing ! curriculum. Also, for everyone who's new around these pots, yes, this is the apprentice level of a 3-part series. So the first 8 weeks is the apprentice level, then we'll be moving up to a journeyman level, which will be the intermediate series, and then a master level, which is the advanced course. All of the courses that we do on this channel will have those 3 parts, except for pipelines only, actually. So maybe it doesn't make any sense to do that. So pipelines was only going to have an intermediate and advanced, and there was going to be an intro to DevOps and SRE that was completely separate because it was actually going to be longer. It wasn't going to fall into the 8-week cycle. We'll figure that part out. But every class on here will have those 3 sections. There is more coming. There's domination coming, which is going to be web development, which is a web development course, which I'm going to get help with from other people because I'm not the best web developer at all. And then we're actually trying to set up one for design, not just graphic design, like user-centered design and doing user research and stuff like that. So we'll check it out. Held a message for a reason. Allow to post. Go for it. Allow. I don't care. Y'all are I trust y'all. Like I said, if somebody posts some crazy stuff in the chat that we allow, one person's gonna have to take the L and accidentally click on it and let us all know that it's a mess, and we can all decide if we want to click on it or not. All right, so let's see. We can call I don't think a key can be empty. I'm pretty sure it can be empty. Let's see if a key can be empty or not. I don't think a key can be empty. Oh, a key can be empty, but you can't have 2 empty keys, I guess, because I guess keys have to be unique. Keys don't have to be unique. Interesting. I don't like this, but whatever. It's not about what I like. It's about what works. So I guess it pulls the last one. That's very interesting. I did not know keys could be like that. Any chance you'll do an Excel course in the future? I am the worst Excel user quite possibly on the planet. If you don't believe me, ask my precious wife. She helps me all the time whenever I need it. I'm like, I don't get it. I don't get it. It just doesn't work in my mind. So I will be teaching it. But if it's something that people like, we're actually gonna be putting out some polls to find out some things that people actually want to learn. We do want to highlight things that are part of the software development lifecycle, but there are a lot of other skills and things that people are interested in. Just to give you guys a heads up, I'm going to be going full time with this stuff sometime this year, and not just the streaming. There's other stuff incorporated, but I'll have more time to do to spend time actually making real courses. So whatever people are interested in are things that we can make. Non-unique keys, that seems like a bad idea. I know, I agree. Like this is really bothering me actually, that we can have, you know, non-unique keys, but that's okay. That's okay. You know, we'll deal with what we got. So that's how we can reference something. But we can also change an item the same way we did it before. Now, before we referenced the indexed location of it, and now because we can't do that, we reference it by key. So you can call the key and you can change the name. So let's try that. Let's say, hey, we don't really like, we don't think, let's put this back for Southern rappers, and we maybe say we don't think Outkast is the best Southern rapper out there, and then maybe we want to change that, and we might want to say best rapper categories of Southern now is equal to a inherently false answer of Kodak, because he's from Florida, and that's the first person who came to mind, even though this is not true. We're living on the edge here. We're living on the edge. And if we print best rapper categories again, it now will tell us that the best Southern rapper is now Kodak, which is untrue. I'm actually upset that I'm spreading this fake news for anyone who's not familiar with rappers and now believes that Kodak is the best Southern rapper, but whatever. But that does change it. So that is how you can change it. You have to reference the key instead of something like this, which was the index. You now have to reference the key here, and you can change the value. Yeah, so that's how you can change stuff here. But how do you add items to the dictionary? So adding items to the dictionary is as simple as adding a key and a value, because you need both. And so we can do that with the same way we reference something here. We can now add, so first off, this has to go away right now. But maybe we want to add a Northern rapper. Maybe we want to, you know, that seems weird to call a rapper a Northern rapper, but sure. We want to add the best Northern rapper, and we're just gonna put Jay-Z in there. It's a safe bet. It's gonna cause the least amount of, you know, anger, I think, if we put that in there. So we'll save that, and we want to add a Northern rapper. So up here at the top, we don't have a Northern rapper category, but now to add one, we're not gonna append an item to the dictionary. We're gonna add a new key. We're gonna you know, set a new key equal to a new value. So we're gonna paste this, and now we have our best Northern rapper, which is Jay-Z. And yes, he would definitely be East Coast. Like I said, Northern is a stupid term for, it's dumb. But yes, we're just keys and values. We're not. We should have a whole discussion about this at some point, though. I'm actually very interested in I love music talk, so I'm a music connoisseur. I don't know if anyone knows, but your boy played I play guitar. So I listen to hip hop, I listen to R&B, but I play guitar. I started playing guitar in college, but I listen to melodic metal. I listen to a lot of instrumental guitarists. Buckethead is probably my favorite guitarist. Steve Vai, a bunch of people. I know a lot of rock songs. I know a lot of I actually know a fair amount of bluegrass and country. I know a lot of stuff. I love the music, so I would love to have some music conversations. So one, I like to discover new music as well. I would love to have tons of music conversations with people and musical arguments, because they are fun to see why people love what they love and hate what they hate. It's pretty fun. And music is one of those things where there's no right answer, so it's not a question of morals when you're arguing. So if you disagree with me, it's fine. It's okay. But okay, let's do this. I'm gonna send you guys, here we go. I'm gonna send you guys some old school Aaron playing guitar stuff. I'm not gonna play it now, but I'm gonna send it to you. Let's see. What do I don't even know what my old Buckethead Ghost Host solo cover. Come on, I gotta be yeah, look at that. 10 years ago, 1,000 views. I'm famous, you know. Woo. We're not playing that, but I'll share it for you. You know, hey, there we go. You know, old. You know, I'm at my campus, my UMBC track and field T-shirt on. You know, the good old days. Have some fun with that. It's amazing. You know, I was amazing. You know, excellent. Okay. So dictionaries, we added an item. So we added our northern wrapper. So we changed an item in a dictionary, and we changed it from outcast to Kodak by referencing the key and changing the value. We can add an item by adding the key and the value here. And then you can delete something from the dictionary by using this delete keyword. So you basically only delete the key, and that removes the key and the value. So we delete, we reference the key here, and that should delete it. So let's see that in action. So let's say we want to instead we want to remove the mumble rap category, because we no longer consider that to be a reasonable hip-hop category. So we're gonna remove it. Dell, best rappers categories, and the best rappers categories of mumble. We're gonna remove this dictionary key. If we remove the key, it's gonna remove the value as well, and we're gonna print it out again, and we're gonna see what that looks like. There it goes, it's gone. We only have Southern rappers now and conscious rappers. And again, I have no idea. This is definitely not spelled correctly. But you know, so I think it was either Blah7 or someone from our previous streams who said, if you want spell check in your code, simply code in Microsoft Word, which I thought was a wonderful idea. You know, we need some spell check to come over to this stuff. It spell checks your function names and stuff, but I want some plain English spell checking, you know? And my phone has taught me how to be a bad speller, so I want that. Okay. Yeah, I'm sorry. I didn't know we were gonna call this. I did not run track. I threw shot put and discus. You know, you're looking at a NCAA Division I all conference athlete in both the shot put and the discus. So yeah, you know, royalty, you know. But no, I did not run. I'm pretty slow, to be honest with you. Well, so I'm not pretty slow. Let me take that back. I actually have a race coming up. But I'm quick. I'm very quick. I'm explosive. But I'm not fast at all. So you know that I have that shot putter's quickness, that shot putter's explosiveness. But yes. So delete is a method of the dictionary. It's not a method, but yes, delete actually works with more things. I don't know what let's actually see. We can just highlight it here. Delete is a function. It's not even a function. It's a come on, show me. Go to definition. No definition for del. It is a keyword. Why can I find it? Let's look this up. Let's look it up, because that's a great question. Python del keyword predict. Del keyword is used to delete objects. So it's so you can use it to, we're going to get to object oriented programming. We're going to talk about what objects are, but I think pretty much everything in Python is an object, or a lot of things in Python are objects. And so the delete keyword will allow you to delete anything that is an object. So it works for more than just dictionary. So here it also works with the list, actually. So we could have done it with a list, but commonly people use the methods that we put in there and not delete. I don't see delete used for lists often at all, but you can use it. So looks like it's used for more than just that. I did shot put and discus too in high school. That's dope. That is dope. I'm actually really considering. I don't have time to coach, but it's interesting because there's like a lot of people don't know that it's something you can do and get scholarships for, and I got a scholarship to school for it. And so like, and I didn't even start doing it until the end of my sophomore year of high school. And I was able to, get a scholarship with just going from there to senior year. And I feel like if more people knew about it, more people would have an opportunity to, get some money for school. And it's something that's fun. It's something that allows you to travel. I got to travel a lot doing it. It's pretty dope. It was actually pretty exciting. And for someone who is a little bit lazy like me, most of your days are spent doing drills, so practicing drills, and lifting weights. So like, didn't have to do a whole ton of running, do some short sprints. We used to cry, like we used to be like sad as a group if we had to do more than like 6 or 8 sprints. We'd be like, come on, like this is a hard day. But yeah, it was pretty fun. Definitely pretty fun. First place shot put, like discus. So we did hammer in college as well. I was an awful hammer thrower, like real bad. But it was fun. It's definitely the most fun. It's super dangerous, to be honest. But yeah. Yes, and Python, thank you. Everything is an object. Most things are object. Yeah. Okay, so just like lists, so very similarly to lists, you can see that the list here, the things that I listed here for you to do, you have the same functionality between all of them. So these are ways you can interact and deal with these different data types, these different structures of data. And so yeah, so just like a list, very similar things, but again, the dictionary differs because it's a key value store. But the difference between those two things is one is ordered, the list was ordered, dictionaries are unordered, and that is why you have to do this. So actually, because they're unordered, check this out. I think it'll mix up, maybe it won't, but we'll find out in a second. Let me print it out. I'm gonna print it out like 5 times. I need Vim back in my life, because that's why I did that. And I'm gonna print it out a couple of times. Let's see if it actually prints in the same order. I'm actually interested to see if it'll print in the same order every time. Sets won't always. Okay, so dictionaries do. That's very interesting. I wonder. But that might be because of the instance in which, no, it's the same time every time. Okay, just wondering. Yes, okay, that makes sense. In Python 3 it will. Python 2 did not guarantee it. Okay, interesting. Cool. So that's dictionaries for everybody, but unordered. Remember, dictionaries are unordered. So let's take a look. Let's go to the next thing. We only have 2 more, I think. All we have left are tuples and sets. And yeah, tuples and sets. And they should be pretty easy because, again, lists kind of covered the main concepts of this. Well, let's go. Oh, no, actually, I like that. I forgot about this. Let's try it yourself. Anyone watching along wants to try it yourself. Let's make a dictionary. Let's make our own dictionary called address with the following keys that you can choose whatever values you like. So keys and values. So yeah, let's try this yourself. Make a dictionary, call the dictionary address. That is the variable name. Address is going to be that, and try to add these things right here to it. Okay, try to do this first. Don't read the whole thing. Try to do this first. Complete these 4, then head down here and try to do this one. And I'll give you just a few. I'll give you just a few minutes. I'll give you a few minutes to do that. We'll sip some more of our LaCroix, which we are out of. And then we'll do it together really quick, just so we can get a little bit of practice. And what's up, Keyline TV? Yes, we did. I mean, we did lists. So yeah, we did arrays. Talk about it a little bit. We're gonna talk about it. Arrays a little bit further when we get to go. But yeah. Yeah, LaCroix. Not yet, but blah. Welcome. Actually, blah. Let me give you VIP. It's good to see you. It really is good to have you back. I haven't seen you in a while. I don't know if you've been lurking. There you go. You are a VIP at this channel because blah is we wouldn't be here honestly without Blah's help. To teach us how to do very basic things. Also, one of my favorite moments of this channel is Blah passed along the sponsorship page for LaCroix, and we spent a few minutes together writing a very heartfelt post from our community to LaCroix to hopefully give us a sponsorship, but it didn't work out. I either never got a response, or I am the worst email checker in the world. I have so many unread emails. I have so many unread messages, period. That I have some structure that I put on all of it, and I'm actually churning through a significant number of it. But I still have a lot of growing to do in that aspect. So maybe they responded and I never saw it. Maybe I'll go back in and I'll search my email for it. But yeah, Blah's dope. Blah's intelligent. Thank you. Good to see you. Even though Blah's also the biggest troll you'll see on this channel, period. So, just know that if you see some wild stuff from Blah, just trolling. A really good troll, really effective troll on this channel. Definitely, for sure, 100%. Okay. Number 0 troll. I like that. You see, we got people one-upping you now. Definitely one-upping you. You are the index 0 troll. I love that. You are even before the number 1. I love it. What's up, Solo Coder? How you doing? What's up, Purple Shadow? I saw you pop in. I saw when you first wrote a message. You've been speaking in the chat for a while. How you doing tonight? Now we finally got a little bit of time to slow down a little bit and say hi to everyone. It brings me so much joy to see people, responding. You're 9 years old. Are you 9 years old? Really? I feel like you're too smart to be 9. You're smarter than me. I love it. That would be cool. Just I'm glad we'll keep our content, we'll keep our words. We won't next time, because they're 9-year-olds on here, we'll skip the dictionary section so that we don't cause any confusion. I don't want to be contaminating little ears. Feel me? Okay. I'm pretty good, man. I'm pretty good, Solo Coder. I don't know. I'm sorry. I keep saying, man, I gotta get out of that habit. I'm sorry. I don't know what anybody is. I'm pretty good, Solo Coder. I'll call you by your name. Like I said, I think I told people before, tonight is me and my wife's anniversary, so we're just drinking LaCroix out of a fancy glass because it's a celebratory night. 3 years of marriage. It was pretty dope. We've been together for like 12 years. What years? I'm 30. We got together when 11. We've been together for 11 years total. Right at the start of college, we got together freshman year of college. So 3 years of marriage is great, but I don't know. It doesn't. We've been together so long, like that, like it's almost like, how could we not have gotten here? If you stay with me if you're with me for 5 years, you just gotta be with me forever, because I'm too lazy to get to know anyone else. So that is the first piece. That's why I'm a lazy guy. I find it very stressful to, like, even the thought of having to ever get to know someone else again would be like, ugh, so much work. Like, I'm not doing that. So it's life is lovely. My wife is allowing me to be lazier than ever. Yeah. What college did we attend? We went to we actually met on the track team at UMBC. She was a 400 hurdles runner, a 500 meter runner indoors. She's like that short sprint, mid distance, not short sprint, like long sprint, mid distance runner, and that's where we met. Appreciate that. Okay, so let's do this ourselves. Hopefully you got to try it out a little bit. Let's just make a dictionary real quick and see if we can do it. I'm actually going to do this. Exit. Let's go ahead and make that real quick. So I'm gonna do it in Vim because I like to do things in Vim. Vim address.py. I'm gonna call it address.py. And what were the requirements here? The requirements were, first, to create a dictionary called address. Nope. Step 1, complete. How can we, let's practice some stuff real quick. How can I confirm that I did that? Maybe I want to do print type of address, even though it's empty. Maybe I want to print that out. And I'm gonna save it, and I'm gonna Python 3, Python 3 address, and the class is in fact a dictionary. So I've achieved the very first item that was on there, even though you didn't need to do that. But we need the following keys. So we need house number, street name, city, and state. So let's go ahead in here and space here. Let's call this house. Well, let's call this house num. It'll be our first item here, and that is going to be our house number is going to be 1 2 3 4 5, the best house number. And what was next? Street name. Street name equals, not equals, colon. Street name is going to be called the best street, the best street in the world, because we live on, we only live in the greatest places. The best street, maybe we call it the beast street, because we are a beast. All right, so the beast street. And what else do we need? We need a city and a state. The city is obviously going to be Baltimore, even though, not my home city. This is my my city in love, I guess. Baltimore. And the state, it's got to be, it feels weird if we don't make it Maryland, but this is a parallel universe. We can live wherever we want, but Maryland. Okay, and so let's go ahead and just print out our address. Let's print that out. So this is what yours, you can call them whatever you want. Yours, just if it's syntactically correct, that's great. And we're gonna print that out, and we have our house number, our street name, our city, and our state, exactly what we just did before. But whoops, we forgot something. Let's add a new entry for dictionary for zip code. So you could have just added it, up here, but let's use the stuff that we have available to us that we learned. So if we want to add a new key, address of zip, we want to set equal to 21123. Sure, that feels right. And let's go ahead and let's print this yank. Let's print it again. So we added a zip code using the method that we learned here, and we're kind of done. That was exciting. Hopefully you got through that. If not, no big deal. What issues did we run into? How do I solve the terminal in VS Code? Yes, you can hit the little X that's over here, or you can hit Control C, should stop whatever's happening. Do you like to write your dictionary in one line or break it into multiple lines? So I hate writing key value pairs in a single line like this. I despise it, actually. I do like to format it accordingly. I generally have some stuff in my Vim to do this, but I don't have my Vim set up right now. You can, in fact, you can, in fact, do this. You can make it look better. And also, this is one of the funniest things. I did not know there the structure of this is so debatable with people. So this is how some people like to do it. I don't do it like this, and I don't enjoy this. I like to write mine like JSON, kind of how JSON's structured. So I actually like this to be indented down one, and I actually like the closing bracket to also be down one, but the format doesn't really matter. White space does matter in Python, but I think this is fine. I'm pretty sure. So I would do mine like this. Let's see if that still works. And it does still work. I prefer it like that. People, I did that in a PR. I did that in a PR. Someone was like, "Hey, dude, this has to change." I was like, "Huh? This is the way. Like, this is so much cleaner. Like, this is like so much better." People were like, "Nah, this is not good." I'm like, okay, well, I didn't know this was such a hotly debated topic. I do like to structure my code like this. Yeah. It automatically adds to the end. Oh, good question. So you're asking if it automatically adds this to the end. It's not the end per se. Remember, these are unordered, so there's no real end to it. But visually, I guess, yes, it will add it to the end, but you can't really think about it like that because it is unordered. It kind of just adds it into the data set. Correct, they are not ordered, so it does not add it to the so it does not add it to the end. It's visually, like I said, it looks like Python 3 will spit it out to you in the same way, but they are unordered. The order is like not structured. It's not a structured order, so it sticks it into the collection. It's not adding it to the end. So do we need to add code to order the additions? I mean, there are, like, you can't really order the additions. I'm not sure what you mean by that. No, lists are mutable. Lists are mutable in Python. Sets are immutable, or unmutable, or immutable. Unless I don't think I'm understanding that wrong. But you can change lists. Oh, the underlying. I see. No. You're right for the that's gonna be confusing for people though. The underlying object. Are you saying the underlying object is unmutable, solo coder? Because that's true. So anything we add, okay, gotcha. So anything that we add will be displayed sequentially. B Bites back. I fully believe you're 9 years old for making that joke. It was good. That first off, the use of the referee is amazing. But yes, you have to come into array. Yep. So they will be displayed, like, so yes, Python does that for you to kind of help out. They will be displayed sequentially, but they're not actually sequenced, but they will kind of display it like that. Okay, so all right, so yeah, so we did that little task there. So let's talk about tuples. Tuples is what let's talk about tuples. So tuples are a sequence of immutable Python objects. So tuples are sequences just like lists. They look just like lists. The difference between tuples and lists are that tuples cannot be changed. You cannot change tuples, unlike lists. And tuples use parentheses, whereas lists use square brackets. So a tuple is, for all intents and purposes right now for you, a tuple is a list, but it's a list that that you cannot change the things inside of. So let's talk about working with a tuple and how it differs from working with a list. So how do you define an empty tuple? How do you define a tuple period? It's with these parentheses. And right here you see, I want to say tuple. Gotcha. Don't do this. Don't do this. But solo coder, your what you were saying is not, we'll get there actually. But I say don't do this. We'll learn really fast why we shouldn't do this. But let's make an empty tuple. Our tuple equals brackets. I'll do this here. So I'm gonna make a new file. I'm gonna call this new file tuples. There's a debate. Some people call it tuples. I don't think it's tuples. I think during the Python course, some people told me that tuples was right. They pointed me at some things. I don't know what it is. I'm gonna keep saying tuples because it feels right. Tuples feels dumb to me, and that's how I live my life. It's all about feelings and what feels right to me. So tuples. Let's define an empty tuple. So r underscore tuple equals parentheses. So instead of let's actually go through this again. So we define our tuple here, but let's also define an empty list and an empty dictionary, just so we can, like, our minds can start to see them side by side and start to attach these symbols to the actual thing. So a list is defined like this, and a dictionary is defined like this. These are the symbols that are needed. So our tuple is defined with the parentheses. But again, for all intents and purposes, lists and tuples are very similar. But they're not mutable. So we can print out our tuple. Let's do that. Oh man. Clear Python 3 tuples.py, and just like everything else, this is not different. It's printing out exactly what we see here. All good. Can anyone think of why I would say, from judging from the information that we just heard over here on this list, why would I put hashtag don't do this right here? And maybe you can look a little farther down. Yes, Keylime TV, very correct. We can't change it. Tuple can't be changed. For us to modify a tuple. So this is kind of how lists and arrays work, or lists versus arrays work in, or slices versus arrays work in Go. Yes, a tuple is, it just can't be changed. So you need to define what you need to define in that tuple right up front. So it works like a list though. So we can do, again, we can add our names in there. So we can do Miss Gray. Is it A or, yeah, not E? I don't know. I'm confused about the E versus A thing, but let's do Keylime TV. All right, and how do you do, I'm trying to pick up some VS Code stuff. Can I wrap? Oh, that's nice. Okay, never mind. I just want to see if I can wrap it pretty easily because I don't know the key bindings for this. Let's go with, I think we already got B-Bytes back in there. I think deGhetto, I like it. deGhetto, or is it deGhetto? Either one, they're both fancy for me. I like it. We'll do Solo Coder. How you doing? Let's go ahead and get you in there as well. And so you all are now, you are now all a part of our tuple. And if we save this and we print out our tuple, you're all there and you're all available. So yeah, that, like, you know what? I mean, for tuples, that's it for real. But now let's check that out. So define a list with values as we just did here. And again, just like lists, the values can be of any of those data types that we learned about. It does not only have to be a string. We could in fact add, the numbers 5 in here or something. And it does in fact work, no problem. And it will work. That really quick. Yep, there we go. I love it. I'm telling you, y'all are my people. I love these jokes. I got you in my tuple. I'm in. Don't tell my wife, but I'm in on tuples. So let's how do we reference items in a tuple? They're like lists for all intents and purposes. So we can in fact reference an item in a tuple by its index value. They are ordered just as lists are. So let's reference that item in here. So wrong screen. Let's head back over and let's print, let's print Keylime. So 1 is Miss Gray's in the 0 spot, Keylime's in the 1st spot. So we're gonna print out Keylime, and we're gonna save it, and not that. And we can in fact reference the same way that we work with lists. So that's why I said once we got a little farther, these will be fairly easy to understand if you already understand lists. It's gonna be fairly easy to understand the concepts here, because you can reference them here. It's an ordered thing, but some of the other things you can't change them. So there's no way for us to change it. So don't worry about that. You can copy these to another thing. You can copy the data into something else and then, move it over. That's actually how Go does arrays. And that's also how it does slices, but it does some magic underneath. Can't change items, can't add items, but you can delete the whole tuple. You cannot delete an item from the tuple, but you can delete the entire one. You can delete the entire one. We're talking constant time with tuples in Python, right? Yes. Constants. So tuples are absolutely like constants. Constants don't work the same in every language. First off, this was a very frustrating thing I found about JavaScript, but yes. Constants and tuples really are just pointing at the placeholder pointer in memory. Some languages, and probably most, you can change the, it's possible to change the what's holding the constant. Let's say you have an array in JavaScript, and that array is a constant. You can actually change the value of the things inside of that, but you can't change the type or yeah, it's really weird. But yes, essentially you can think of these like constants. We'll get a little bit deeper into the the differences of those. Actually, I have a very specific algorithmic problem that's going to highlight some of the differences between these. Okay, and so yeah, you can use the delete keyword to, again, delete that entire object. You can't delete an item, but you can delete the whole thing. And so let's see that happen. Let's print out our tuple. Let's delete our tuple. And then let's try to print our tuple again and see what happens. See what we get here. Our tuple. I'm gonna save that. And check that out. It prints out the tuple up here. And then we get an error. And why do we get an error? We get an error because it says our tuple is not defined. And that's because we deleted it. So it's no longer there. It's completely gone. Returns parentheses when you print. So tuple kind of like a single object with an index. Correct. That is true. All right. So very similar to a list. Now on to the next and a surprisingly useful data type data structure is a Python set. Let's share so you can see our great community meme. For anyone who is not a community fan, please indulge yourself on Netflix. It is now on Netflix. It is an excellent show. It's pretty funny. I never finished it, but I'm going to because now it's easily watchable on Netflix. So what is a Python set? What is a set in Python? A set is a collection which is unordered and unindexed. So you cannot, that should already be telling you, I cannot use those index numbers to identify items in a set. In Python, sets are written with curly brackets. Think dictionaries without the key. So what show, this is a community. It's called Community. And like I said, it's on Netflix right now. It's pretty cool. But so if you see curly braces and there are no keys and values, they're just values, that is a set. And sets have some interesting properties in them, but they are unordered and unindexed. So let's set up a set. Close this. Create a new file, set.py. All right, so a set.py is going to be our set is going to be our set is going to have you know, maybe what's up, Zosam? How you doing tonight? Let's see. Let's what is something that I enjoy? We got our 3 starting Pokemon on the back wall. Now I'm not I actually don't deal with Pokemon past the original 151, to be 100% honest. I dove into, you know, the gold and silver timeline a little bit when I was younger, but let's make our set of Pokemon. So let's put our starters in there. If you're unfamiliar with Pokemon, you should become familiar with Pokemon. This is my childhood. It really is my childhood. What do we got? Squirtle, and the unsung hero, which is Bulbasaur. People don't give him enough credit. Bulbasaur. He's a little frog with a plant on his back that grows. He's, I think he's a frog. Seems right. And then maybe, all the Pikachu, the one that everyone knows. It's a pretty stupid, dumb Pokemon, to be honest with you. But yeah, all right. So we got our set here, which is these things. So 4 items in our set. Let's see what we can do with this set. Define an empty set. Defining an empty set is different from defining everything else. I just defined one with values. So let's print this out really quick. Oh, I actually didn't do, oh yeah, I did. Our set equals new. I keep forgetting in VS Code, I don't need to like, I can click around my mouse. So print our set, and let's just take a look. Again, not much different. What? Oh, I ran the wrong file. The file that I want to run now is, what is this called? Set.py, and we get our set. Again, it prints out just like before. No real changes there. But we didn't do an empty set. Let's define an empty set here. So let's do empty set, and notice that it's different. Notice that the way that you define it is actually different, and you have to actually call a set function here, and that will a new empty object set. And let's print that out. I'll print out empty set, and let's see. So it just prints out this here. So yeah, so that is how you define an empty set. Pretty interesting. So great question, Sean. It looks like a dictionary, but it's a dictionary without keys. Without keys basically, is what it is. You cannot reference an item in a set. It's unordered, unindexed. You cannot reference an item in a set. Can you change an item in a set? Absolutely not. You can't change an item in a set. But you can add an item to a set, and you can remove items from sets, which is interesting. I'll show you what you'll use it for in a second. It has some cool side effects. And so actually, you know what I want you to also see? W3 Schools has some interesting stuff about Python sets. And again, curly bracket example. So I like the stuff that they have in here because I think W3 Schools walks you through it pretty well. So let's go through here real quick. So you cannot access items in a set by referencing an index. So we said it was unordered and it was unindexed. Since sets are unordered, the item has no index. Cool. But you can loop through sets. We are gonna not do that right now. We're gonna learn about loops. We're not gonna loop through sets right now. Sets are loopable, and this is why, like, the reason why you would use a set is because you can, although they're unordered, unindexed, you can still iterate through them, which we'll talk about iteration, but you can kind of move through the items that are in there. And you can also use sets to also, I don't know why it does this, and maybe maybe it's something we can look up real quick. It's also used to you can get it to remove duplicates in like a list or something. If you convert a list of things to a set, it would actually remove dupes. I don't know why it removes dupes. I don't know why, but yeah, pretty interesting. Pretty. Yes, it does. Python does have arrays, kinda. And again, when I say that, the first thing you do when you get here is that it does not have built-in array support. Lists are used instead of arrays, but there are packages that allow array support, which is NumPy is the one that people use, that will get it to act a little more like the array that you know. Yes, it does not have arrays like Java, but out of the box like Java or like Go. It's not the same thing. Yes, it can unique automatically. So let me like if I have maybe like Squirtle in here again, I'm pretty sure it'll do it just like this. I don't know if it only does it when you convert or if it does it like this, but let's find out real quick. And I only learned about this we were working on a little small algorithm to dedupe stuff, and I was trying to show how to do it manually because the goal was to learn how to do it manually. And somebody was like, you can just use a set for this, and I didn't know that actually, and it worked. I'm pretty sure that's what it was for. Yeah, and look at that. I added Squirtle in here twice, and it only prints out, you know, it's only in here at one time. So you can use that to, you can cast a list. So maybe like if this was a list right here instead, a list would print out. So if we change this to a list simply by changing the brackets here, and we printed this out, Squirtle is going to appear twice. Oh, actually, well, yes, it's still right. Squirtle is going to appear here. Oh, actually, maybe I did do that wrong. Let's see. It appears here twice. Let's change that back to make sure I know what I'm talking about and I'm not being a big dum-dum. Let's see. Save. Yeah, okay. Squirtle's only in here once now. So it's in here twice when it's a list. It's right here and right here. As soon as I change it to a set, it's only here a single time. And you can see that the order switches up a bit because it's unordered. But let me change this back to a list. And let me cast it to a set. So I'll save that real quick, just so we can see. As a list, Squirtle's in here twice and it's ordered. But as soon as I cast it to a set, and I print it out, you can see here that Squirtle is only in here once. What's up? Is that Lafioska? Welcome to the channel. Thank you so much for the raid. How are you doing? I don't have a defend or attack overlay. Good to see you. Thank you so much. I really appreciate you coming through. You are coming through close to the end. We're gonna do a little bit more, but we've covered most of the main concepts. We're now gonna take the concepts that we learned and see them in a more difficult space, which is Go, to be 100% honest. But yeah, it'll still be fun. It'll definitely still be fun. So welcome to the channel. Thank you so much for the raid. I'll give you a shout out. Definitely give you a shout out. Is that, man, I need to fix my font because I don't know Lafioska. Did that work? Yeah, there we go. All right. Raiders pop prayer. I love it. There we go. Okay. Here we go. Let's see some of the stuff in Go now. And what I'm gonna do is, to make it way less confusing than just typing it out, what we are going to do is, there's a great site that I gave you in the beginning, I believe, called Go by Example, but I'm going to give it to you here as well, which is for beginners, not so much a great site. It is not a great site for beginners, to be 100% honest. It is a great site for someone who knows another language, who wants to reference how to do something in Go. So if you already understand all these concepts, yeah, it's a great place to just go and see a quick way to kind of implement some of these things. But you don't need to. So I would open up Go by Example. I'm going to paste this here. And then I'm going to paste the Go Playground. Go Playground. You can open up both of these if you want to mess around. The stuff that we're going to look at is going to be much more complicated here. It's going to look so much harder. And that's why I didn't want to do them both at the same time. I want you to understand the concept of those lists and things. In Go, they are very much the same. Actually, I want to show you one more thing. My bad. Before we do this, I wanted to show you that in lists, you can also do, because we're going to do this in Go a little bit as well. Let's go back to our list file here. We had a couple different things here. You can also do things called slices here. So maybe you want to only grab part of your list, just a piece of it. What you can do is, because lists, you can access things by their numbers. Let's say I only wanted the last 2 items in the list. I could do a colon here, and so I could do a colon here, which is on the left side is going to be the start, and the right side is going to be the end. So I could say I want everything. Let's say if I wanted everything from Chelsea Carter to Heezy L. This is in the 0 spot. This is in the 1 spot. So I can say I want everything from 1 to 2 and 3. So from 1 to 3, and it'll print out everything from 1 to 3. So I basically, well, wrong thing. Python 3 list.py. Oh, it's non-inclusive. Sorry, it's non-inclusive. So it needs to actually be 4. So this number is outside of the index, but it is yeah, it's not inclusive. So it goes up to this number, but not including this number. So it only printed out these things. I could also do stuff from like the beginning to just the third one and stuff like that. So there are methods. Now I don't need you to know slices right now. I just want you to understand that there are methods for being able to split up these lists and only identify parts of them. If this list was 100 items long, I could do like if I wanted numbers 55 to number 93, I could do that like that, and I can get numbers 55 up to 92 actually, but I could do that. And I'm only displaying this because the way that you do lists per se, that we're used to, the way that you do lists in Go is actually something called a slice. So there are arrays do exist here, but so here's an example. It's going to show you. We're gonna copy and paste some of this, but what actually I think you can just click and go to, maybe not. Let's take a look at the code over here a little bit. Already, like I said, I know it's probably pretty overwhelming. Arrays in Python, arrays in Go, they cannot be changed. The number of items in them can't be changed. So right here, we're defining an array of integers. So arrays are defined by these, but we also have to tell the type. Remember how I said in Python, you could do all kinds of stuff. So I could add a number in here. I could add in a Boolean in here. I could add a Boolean in here as well. I can mix things up. In Go, that is not the case. When I go to create, I'm going to go do this in a second. When I go to create an array, one, I have to define it up front. I have to, set it up front. But it has a specified number of places. So I have to know exactly how many things are going to be in that array. So this right here says, all right, Go, I'm setting up a variable called A, and it's going to be an array of 5 integers. This is an array of 5 integers, and I can only have 5 integers in there. So let's see what that looks like. And actually, there we go. Yes. Thank you for pointing that out. You can go up in the top corner and you can click the little thing and it'll take you to Go Playground, or you can copy your code here. We'll go to the Go Playground and it'll take you here, and let's run the code first and we'll walk through it. So I'm going to run it. And it spits out some stuff, but that's fine. What I'm going to do first is I'm going to remove all of the comments because those are kind of confusing. Built in. This actually might be better in our editor because it will be a little, you can copy it here. I'm actually going to copy it so we can get some colors. I think the colors are going to help kind of, I think mentally help go through this. So let's create a new one and let's do, there we go, arrays.go. And we're going through this real quick. The goal is not for you to know Go, just to kind of contextualize this against what we just learned, is all we want to do here. All right, so first thing it's doing is it's defining an array of integers. So it's saying, hey, set up some space in the memory for 5 integers. Remember, this is a compiled language. Everything happens beforehand. So we're telling, set up a variable for me called A. Actually, we'll change it. We'll make it our array. So it makes it a little easier for you. Var our array. And we're saying, hey, make it consist of 5 up to 5 integers. And then this says print A. So A will be empty at first. A will be, so this is just like a string here. So if we remove this and we can say, go ahead and print A right here. And this will print in our empty array. Let's comment out the rest of this actually and run this. All right, so we're only gonna run just this right here, not A. We need to print out, we called it our array instead, not our array, our array. All right, so let's run this really quick. Go run, what is this called? Arrays.go. And it prints out an array. So you see those brackets there. So that denotes an array, but it's filled with 5 zeros, Why is it filled with 5 zeros? One, remember last time we talked about zero values. So the zero value for an integer is 0. And remember, we told Go that this array was going to have 5 integers in it. So it filled it out with 5 of the 0 values. So that is how it did that. So we could change this up, and let's see what it looks like when we change the type. Let's change it to string. So an array of strings, and it just gives us these this blank array here. If we say it's going to be 5 booleans, we get false, 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 false. So the 0 value of these things. So already in Go, it's a little more complicated because you have to tell it what's going to be in it, and it can only consist of a single type. All right, this can be pretty that can be pretty wild. It can be pretty confusing when you first kind of start out. But yeah, let's look at what they did past this. So what they did is they said we'll change all the A's to our array. They said our array at the 4th index now equals 100. So we have to actually change this back to integer so that it works. So they change it to 100, and let's print out what that looks like now. Let's print out our array. So this is kind of what we did before, and we can assign a value to the indexed place of that. So we'll save that, we'll run it, and look at that. The 4th index, we set it to the value of 100. But it changed the 5th number. Again, take it on back. Take it on back. This is not a 2D array. This is, I just printed out 2 different arrays. Maybe I'll just remove this print. Make it a little less confusing. Remember, take it on back. This is the 4th index. So 0, 1, 2, 3, 4. So this is the 4th index place. We changed that to 100. So you can edit them like that. The next, yeah, this will be 2D right here. We're not going to go into that piece down here. Oh yes, you can also define it like this. So you can check the length of these things as well with len. So that's what they're showing right here. So just like Python, I could also do like let's check the length of our array instead. And you can in fact see that it is a length of 5. So we do have that same ability, again, just like in most other languages. So we do have that option here, but what we also have the option for is defining. You can define the array with values right up front, and this is how you would do it. You would do it by basically using that walrus operator. So, you know, this is the integer we're defining. So we didn't do this piece. So this is a completely separate integer. I mean, a completely separate array. So this is, let's comment this out. And down here, we're defining an array called B, all in one line. So this is the shorthand method we kind of learned a little bit for defining variables. So we're gonna set the variable B equal to an integer array that has 5 items. And we're gonna define all 5 items right here. And if we print that out, we can see that the array now has 1, 2, 3, 4, and 5. But again, remember, in Go and most compiled languages, arrays are they're kind of static items here. They're immutable. You cannot change them, and so most Go knows that. Go knows that like that's hard to work with. The way that you do operate with things like this is, again, you basically take this one, you copy its contents to another array, you add in whatever you need to add into that new array, and that's the new array. That's kind of how it works. And that can be pretty annoying when you have to do that manually. When you want to change an array in a program, arrays are used heavily in programs. You want to do that manually, that's a cumbersome task, and it's super whack. So Go, most commonly, you're not going to be using arrays. No one uses arrays. You use something called a slice, and slices, they're arrays underneath, but they add in all the magic for you so that you do not have to do all the copying. Equals versus colon equals. How do you remember when to use these? Great question. It is something that's very confusing, actually. The colon equals that you see right here in Go, You only use it when you are defining the variable. So the first time the variable is being created, when you're first defining it and assigning it a value, is the time that you use this. So the very first time it comes up, you use that. But whenever you need to make a change to a variable, you do not use this. So you can only define a variable one time. You can only declare a variable one time. So remember, the act of declaring a variable is actually creating a space in memory to kind of hold that variable. You can only do that one time. If you try to do it again, the computer will say, hey, I already have that. Like, you can't create a new space for that same thing. So this is creating it and giving it a value. After you create it, all you can do is change the value. So this only happens once. The equals can happen many times. Yes, slices like an array list in Java. Yes, so slices are similar, but these are things that can change, and these slices work much more like the list that we just learned in Python. You can, we're gonna set one up in a second, but you can do everything here as kind of you would before. You can even append. The append looks different, but the way that you add to these is you use the append method. And again, look, the syntax is different, but we can add to it that way. And we can delete things from it as well. But yeah, it works very similarly. So let's take a look at that. Slices also, you can operate with them using the slice method that we kind of just work with in Python. So let's do a new file, slices.go, paste that in there. Let's comment out all the 2D stuff, just because again, we don't need to know all that right now. We'll get there. We're gonna get there. We're gonna get to all that stuff. Main. That's right. Oh, all right, it's because I have another file in here already. Okay, so this works a little bit differently in the way that you create them. And the reason it works differently is, again, because these slices are actually using arrays underneath. It is an array underneath, but when you want to do stuff to it, it adds the magic of copying this array to a new memory location, copying in all the data, and updating that array accordingly. So the way they're making an array is they're using this make command, this make function, and you still have to define what's going to be in that array. So slice. So they did they made a string, a slice of strings, and that's how you say these things. That's how you refer to these things in Go. You refer to it as, this is a S is now going to be when you see these brackets, it's a slice of strings. That is what this data type is. It's a slice of strings. 3 is in there. You can I actually don't think you need to define the amount, but I think that'll give us 3. I don't think you need to define the amount, I'm pretty sure, but we'll see. Format.println, let's go ahead and just print out what that empty slice looks like really quick, and let's print out, S here, and let's comment out all of this. All right, so what it's gonna do first is it's gonna print S after we originally make it, where it's kind of empty, and then we're gonna add some things to it, and let's see what happens here. Run slices.go, and here is the empty array. And then check this out. This is exactly how we did it before inside of Python. We specified the index value. So S at the 0 spot, we're now going to make that A. S at the 1 index spot, we're now going to make that value B. And S at the 2 index spot, we're now going to make that C. And so then when we print it out again, those all did get set there. So that was adding those values when we already had space for them. So we already actually had 3 spaces for strings there. But then we can do the append method. So we can take this, and the way that append works is you use this append function and you say, hey, I want to append something to S, and this is what I want to append to it. So I know it can be pretty confusing, but I'm going to add to the S variable, or to the S slice, I'm going to add in this value. So this is what you're adding to. This is the value. You don't need to be worried about remembering that right now. And so let's actually comment this out and print out the appendment, the appendee, or whatever you want to call it. And there we go. When we append it, it did in fact add one more. But let's see what happens when we add these two. This is adding an E and an F. Let's see what happens. You can also add in whatever amount of options you want with the append. So the first item is what list you're appending to, or what slice you're appending to, and all the things that you want to append go ahead and go in after that. Oh, you want to see, length too, please? Yeah, there we go. Yeah, let's do length of, same thing. So if you want to check the length, it is the same thing. You just call length of S. It works just like the arrays. So we should see a number in there, which should be 3. Whoops, not arrays, run slices. We see this 3 that pops up in here, which is this line right here. And just so you know, it's a, so you can see what it is. What's the best way to do this? Can you do it with a comma? Yeah. Just so you can see what the length is, give you a little bit of a indicator. You can do the length of these as well. So one, I want you to start to see that like the concepts are the same across the board. So like the checking the length of something is the same, and the method of knowing that you can have a collection of these data types, you know, arrays, whether they're arrays, slices, or lists, or whatever, is the same across whatever coding language you go to, like you go across. Like you have a method for having a collection of those data types. They may work differently underneath, but for the most part they're the same. We're just printing things out the same way that we did before. You know, length you can add using append. You know, there's methods to add to these things and remove from these things. So yeah, it can get pretty confusing when going back and forth between them, but you can do these things. So you guys have, it's great. Just got rid of that annoying text from the Go site by using the DD and yep. Yeah, I respect. The first time when I started to learn like the easy like D functions, like the D commands inside of Vim. So maybe things like Vim, what are we in? We're in we're in slices.go. First off, the one that got me the most is when I found out you could easily delete like inside something. So like, let's say I go to so I go over here. If I want to delete everything inside the parentheses, you can just do that. Look at that. One quick command, super nice. Delete inside. You can like delete inside your quotes or whatever. I found that to be incredibly amazing. Or like even just simpler stuff like delete to the end of the line, or delete to the end of the file. It's really nice. It's so dope. But to delete inside something is you got to be inside of it. So like even the quotes, like even like, let's say there's a bunch of stuff inside of these quotes right here. To delete inside of the quotes, it is DI for delete inside, and then a quote. You do a quote and it deletes everything inside. So it's pretty interesting to do things like that. And then I can just go delete inside the parens. I can delete that stuff as well. Super nice. Really fun to kind of play with. Like it makes you feel really cool when you start to get comfortable with the stuff and go super duper fast. I use Vim. I use what you're looking at now. I use Vim to edit things. I don't really use like VS Code. I recommend VS Code. VS Code is amazing. There's no reason not to use it, to be honest. The reason I use Vim is because work with a lot of systems, and you know, they don't always have a editor. So I just want to keep my Vim skills sharp, and Vim is fast. Like, the learning curve is incredibly high, and kind of getting your setup can be cumbersome, but once you do, it can be a lot faster for a lot of things that you want to do. Okay, slices, and really maps is going to be like your dictionary stuff. So I actually recommend, if you want to learn a little bit more about some of the Go stuff, I'm gonna add this in right now. Actually, here we go. Let's do this real quick in the classroom, just so you can start to try to tie some of the Go stuff to the Python stuff that we learned, the concepts. Let's go to deCoded real quick, and let's go with classwork. Let's add a material. Let's see this, dictionaries for Go, and I'm gonna add this link in here. And while we are I also want to be clear that for anyone who did come for Go, while we are learning these concepts, some days we're going to primarily be focusing on Python. Some days we're going to be primarily focusing in Go, because there are concepts that we're going to be touching that make way more sense to learn them in Go, and it's actually going to give you a clear understanding. When we get to the section where we're doing algorithms, we're going to be doing them in both languages. And we're probably actually going to be doing a lot of them in Go first, because Go is not going to give you some of the magic, and you're going to have to think, you're going to have to actually implement it a little more. But again, the concepts will be they'll be relatively simple to move over. So we'll be writing a lot of Go. Tonight we wrote a lot of Python, just because of as you can see inside of Go, some of the stuff can just be much more taxing. But that actually changes a little bit when we get to the algorithm section. And I know that's, you're like, how, if the underlying things that we're learning, are more complicated? Trust me, when we get there, it'll make a little more sense. But I'll do this for anyone who wants to dive into that. Since we did not get to do that, and slices are like the arrays and the sets and stuff. So that's like really the only concepts. Those are the basic data structures and data types that we kind of want to learn about. And again, for anyone who's looking for the data structures that you would learn in a full computer science class, again, those things like hash maps or linked lists, or those multi-dimensional arrays, we're going to get to those, not in this course, but in the intermediate level of them. So it'll be pretty dope. But yes, we're gonna be doing a lot with, like, the algorithm section is gonna be fun. Like I said, we're gonna be doing a bunch of stuff on exorcism. We're gonna be diving into the common algorithms. We're gonna be learning, again, the different all the different sorting methods, and all. We're gonna be learning all of the base level things that we need to learn, and you're gonna feel pretty cool when we get there. It's also gonna make you understand the algorithms aren't so crazy. Now, there are crazy algorithms, but the word algorithms does not need to be scary, because it's actually quite a simple thing. But that's it for tonight. 9:36. Let's get on out of here. Let's wrap it up. Tangible takeaways for tonight. What, if you're going back and you want to make sure you understood what we got through tonight, what you want to understand is that there are structures in programming languages that allow you to work with data easier. There are different structures that you can set up to work with data easier. These data structures that we learned tonight are also, at least in Python, they are data types. They are in Go as well, kind of. But we want to know that we want to know that these data structures are collections of data. They're collections of pieces of data, of elements of data. We learned a little bit about lists in Python. And it's kind of just important to know there the concept of lists is the thing that we want to pull out from that, is that there are data structures that are ordered, and there are ones that are unordered. So we know that list is one that is ordered, but ones that are ordered means that we can access items in there. They are indexed, and that computers zero index these items. So zero indexing is really important to kind of know and understand. So the first item in these data structures, it starts with 0 rather than 1 or 2. And you can use those items because they're ordered to identify the location and be able to access those things accordingly. We also learned that there's a type of data structure that will allow us to have keys and values, or that are basically key value stores, which are dictionaries. In JavaScript, this would be, this would be JSON. To be 100% honest, they have some other options for that as well. But there is a structure to kind of create a mapping of items to a key and a value. And Go, those would actually be maps, but there is a way to do key value stores, collections of key and value stores. Different languages, those are ordered, but they are unordered in Python. And we also learned about two other list type things, two other array type options in Python, which again are tuples, which are lists that cannot be changed. So you got to be careful there. Use a list when you know the things are going to be changing. Use a tuple when the things are not going to be changing. And a set, which is an unordered, unindexed list as well, that also dedupes for you, but you can use it. Well, excuse me. It's really good because you can iterate through it really easily, and it can, there are specific cases in which that's great. We're gonna see very prime examples of when to use, when it's a good idea to use some of those. There isn't necessarily a wrong answer for a lot of them. You can use them sometimes, depending on your use case, you can use them interchangeably. But again, you got to keep in mind the caveats of them to determine if it is or not for you. But dope. Go is my main language, for sure. Well, Go is my preferred main language. I write more JavaScript nowadays than anything, just because of my work project, but I don't love JavaScript. I do like it. I don't love it. But Go is the language I like the most, and that I've built the most complex things in. It's probably the language I know the most. Like, I have the most tribal knowledge about. Like, I know more of the documentation and stuff of Go. So yeah. But yes, you should practice over the weekend. Someone should do a live mastermind homework stream. Someone should. Yeah. How many do I know? Honestly, the only language that I'm confident to say that I know is Go, and I know JavaScript. Am I good at JavaScript? Debatable. Go will be the only language I say I know. I know Python fairly well, but just because I don't get to use Python that much anymore. I feel like there's so many just things that I just don't know about Python. But I'm very confident. I'm very confident in my ability to build an application in Python. If we had to build something right now, and we need to do it in Python, I'm very confident I could do it. I'm actually pretty confident I could do it in just about any language, because again, once you pick up the concepts, it's actually pretty easy to move to different languages. But I could do it relatively quickly in Python. I could probably do it the quickest in Go. Probably the next quickest would be JavaScript, then Python. I could do a fair amount in Ruby as well. I've touched Ruby a little bit, but I'm far from a Ruby developer, to be 100% honest. But yeah, yes. And honestly, once I moved from one language to multiple languages, I really like I started with Python actually. Well, I started with Bash, and I guess some people I learned the concepts in Bash, and I got worse at Python when I started to spread my wings. But I became a better programmer, but I got worse at any individual language, to be 100% honest. Chelsea Carter, no, the only homework is to, especially since you just joined, the homework is really to kind of maybe get up to speed with the other previous ones to this, to just kind of give everyone a chance to, we had a tough week last week. There's a lot of information, but just to kind of get everyone on, give you a chance to kind of catch up, get on the same page, explore a little bit. The homework is to explore, is to try some stuff out, Google some, just read, say, hey, what should I know about Python? What should I know about data structures? What should I know about data types? And it's gonna take you on a journey. You're gonna learn a bunch of crap that you have no idea about. You're gonna learn a bunch of stuff that you should have no business learning right now. But one day those dots will connect as we kind of, learn more and more and more. Because again, next week there's actually already there's actually a significant amount of material when we start to get to the problem solving sections of this. And I want to make sure you're not burned out before then. Yeah, so just take it slow, no big deal. It's okay. You fall behind, great. The videos are going to be there. It's all, it's nice. We're doing this together. But also, again, I just want people to feel like, even if you do fall behind, still show up to, like, it's not, each class isn't like crazy dependent on the last one. There are concepts that we may touch again, but like, it's okay if you miss stuff here and there, and you can go back and pick up things. It's okay if you don't fully understand something before we move on to the next thing. So yeah, just keep that in mind. Just keep moving. That's all. The only goal is to keep moving. Progress in coding is progress. I think one of the biggest problems is it's so easy to fall off. Like, we all know, if you want to go get swole, you know that if you go to the gym and you know how to do it. Like, it's hard, like, you may not want to do it, or maybe hard for you to do, but if you go to the gym and you start, you put weights on that bar and you do the thing, you practice, you lift, and maybe next week you add more weight and you lift it, you're going to get stronger over time. Same thing if you want to run faster or run longer. If you just go out, you got to practice, you got to do it. But even if days are bad, even if you have a day where, sure, I wasn't able to lift as much as I was able to lift yesterday, that's still progress. You're still training your muscles, you're still training your nervous system, you're still training your body. And this is kind of the same way. Yes, you'll get to days where it feels like you did not understand anything we went over. There's a lot of learning still happening there. It's uncomfortable. Growth only comes when you're uncomfortable. Like, this is not some philosophical thing. This is like physics almost. Growth only kind of comes growth is a destructive process, actually. Like, getting stronger, getting smarter. Animals, when they get healthier, when they grow, they shed off their skin. It's a tough process. It's a process where something is broken down. So the growth it really does only happen in discomfort. Unfortunately, you got to go through it. But we're going through it together. When you do feel uncomfortable, I promise you that's where you're growing, when you're uncomfortable. So yeah, that's it. We'll be able to use resources for our quizzes. Yeah, absolutely. When you are working, there's no you don't have access to the internet. Like, Google is your friend. Use every resource you have available to you, including asking each other for help. Now, I don't want you to ask each other, don't say, hey, what's the answer number 5? But if you're having trouble, like, you have, when you're working in the industry, you have coworkers available to you to ask questions to. So use those resources. Like, learn how to use your resources to get the information that you need. If there's somebody in the chat who's giving you all the answers, hey, that's what you have available to you right now. But use that information that's given back to you to learn. Like, don't just copy and paste people's answers that they give to you, but use that information that you pick up to truly understand what you're trying to do. But yeah, like, use all those resources when we get there. I'm just raised tonight. I get it. Thanks for hanging out. We're about to raise somebody right now. Thank you everyone for a great night. Me and my wife are gonna go drink some more LaCroix. We have some more flavors, so we're gonna go drink some more LaCroix and just enjoy each other's company. We have some nice Italian food. She probably already ate, because she's living a fancy life. She works, and she's an EMT. She's really great, and so she's like saving the world sometimes. And she's also getting her master's right now in nutrition, so she has class and stuff, so she's doing a bunch. So sometimes our schedules are weird, but we're gonna go relax for a little bit. So everybody have a great night. Enjoy your Friday, and it's a long weekend coming up. We are still having stuff on Monday. I understand if you can't make it. Saturday we have pipeline, so I'll see you then. But if not, we'll be back next week. Who are we rating tonight? Because we consistency is key. We can't not do it. So let's see who we got online tonight. In the Science and Tech popped up right here. That's great for me. Prime's here. What's our raid message? Great question. We need a raid message. I don't know if anyone has one. Definitely throw something out there. Let's do something from what we learned tonight. Sure. Let's see if we can find anyone who is doing anything like that. These people are paired programming. That's actually kind of cool. Paired programming is a great thing. Actually, you know what? Next week, we're gonna talk about paired programming. That's a great idea for you to do for your homework. And Visual Studio Code allows you to easily pair program. I love this. Oh man, maybe we'll go over and say hi to them. If anyone sees anything, Alt F4, what's up, man? First off, shout out real quick to Alt F4. I do. And I saw your message in I saw your message on my phone pop up in Discord. I will be responding to you. I promise. I promise. Shout out to Alt F4 stream. There we go. Yeah. But yes, I definitely so I'm pretty booty at Valorant, but I'm decent, but my teams always lose. Even when I get like, I'll be getting like top fragger all the time, my teams lose. Maybe I'm a bad team player, who knows, I'll figure it out. But yeah, I'll definitely hit you up. But everyone check out All F4, a pretty dope stream. I learned a lot. You're also building some amazing things. You smart dude, really smart dude. Okay, I like the pair programming person. If anyone sees anyone doing anything that we did tonight, let me know. But I think we're gonna head over to the paired programming thing, because I think it's a super valuable thing. Maybe they can teach us how to do some of that paired programming. So let's head over to Trevor Blades. We're gonna raid Trevor Blades. So raid Trevor. I can't type Blades. Let's go. When we get over there, let's say hello. Invalid username. Oh no, yeah, sets are not dictionaries. I like that. That's perfect. That's the perfect raid message. It's amazing. /raid Trevor Blades. Pretty simple. Okay, I got it right that time. We're gonna head over in just a few seconds, but let's all say hello. Let's check out what this pair programming is about, so we can see how we can implement it next week. Peace, everybody. Have a good weekend. Have a good night. See you Saturday if you're gonna be on Saturday. If not, enjoy some, take some time to take a break as well. This stuff can be overwhelming, but let's go.